right now. Hey, am I live? Hello. Hey, hello, wonderful people of the internet. Welcome back to another episode of Leos Labs. So, we are starting on YouTube right now. This is the start of the live stream on YouTube, and what I want to say is I want to have like a very brief discussion about YouTube at the start of the stream. The reason being that, to be honest, no one on Twitch watches the very start of the stream, and pretty much everyone on YouTube only watches the start of streams. This is the perfect time to talk about YouTube specific stuff. And that is the following question. Do you watch shorts? That's my question. I don't know if anybody's actually watching this. I don't know if anybody's going to like go down in the comment section, but if you do have something to like say with this discussion, I'm very interested in your opinion. So I'm not someone who watches shorts because I don't really use my phone that much. Like I'm on my desktop most of the time. And so, you know, this factor, you know, the ratio here where we have like 16:9 and it's horizontal, like that's how I watch most of my content, right? However, I know a growing number of people watch, you know, vertically because they're watching on their phones, right? And so as I was starting to make this animation, which you see in the upper right-hand corner just above me, I started wondering if maybe the appropriate venue for this animation is not like a full-on YouTube video, but instead a YouTube short, right? And I have a lot of thoughts as to why this could be the case. The first of which is that, you know, like the video short, it's only like 2.5 minutes, and that's kind of perfect for shorts length, I think. I think most shorts are that length. I'm not entirely sure. I feel like the animation can be like very compelling. It can look very pretty, and that's really nice. And I kind of have this idea of like elevating what type of content what type of content people make on YouTube Shorts. That's also something I kind of had in mind. So anyway, I'm curious to see what people think about this. Instead of doing like a full, like, you know, traditional rectangular, horizontally, you know, video like this, if instead we make a short and have it in this form. I'm kind of leaning towards the short now just because, again, the content's only 2 minutes long. And, you know, actually, the truth is I have this weird thing about YouTube right now. We're like, okay, I want to watch. Here are the videos I want to watch. I want to watch the following. 1, a 3-minute video. But I don't want it in shorts form. I want it in desktop form, but I don't want a short. Right? I don't want shorts, right? I don't want a live stream. Right? So I do want a live stream, and I do want a 3-minute video that's not in short form. But what I don't want are these like long, like 30-minute videos that are horizontal, right? This has always been my issue with like 3 Blue and Brown and people like this. And not that their content isn't great, their content is amazing, but I don't have the time or the attention span to sit through a 30-minute discussion like this, right? If it's a live stream, that's one thing, because like it's live, you know, we're talking, there's engagement being had with the chat. There's so much about a live presentation that is different than a 30-minute standalone video, right? And if you actually go back to my YouTube channel, let's go youtube.com /c/LEIOSOS. I messed up. youtube.com. Let me go here, and let me just go there, and let me go to my channel. Here we are. And let's go here to videos. Look at my videos here. Like, okay, this one I probably could have done as a short. That one I definitely could have done as a short. Let's see, let's go down to my more popular videos. Let's go by most popular, right? This one, 3 minutes, 57 seconds. I could have probably compressed that into a short. This one, eigenvectors, I could have compressed into short. Determinant, short. Monte Carlo, short. Impossible lenses, short. All of these could have been shorts. Like almost all of my most popular videos could have been shorts. Gift wrapping algorithm, all of these fit into short length, right? And so the question is, why am I making normal videos if I could just turn them all into shorts where people are actually already wanting the short form content, where the long form content is now turning into these like 30-minute long, like unnecessarily long videos so people can like throw in I guess mid-roll ads and stuff like that. You know what I mean? Like nowadays I feel like the normal YouTube videos have become longer and longer to account for the fact that shorts exist, you know? And I just feel like, I don't know, I liked the short form, like horizontal videos. That's what I used to like. But now I don't feel like there's a market for that. I don't want shorts, many reasons, one being that I view anonymously, and doing that means Google plays video at full volume. But I was under the impression that most successful shorts are 15 to 30 seconds, quick and to the point, but shorts can be up to 3 minutes, and that was more of a recent change, so perhaps that has changed. Okay, in that case, maybe I think maybe this video will remain as a standalone video. Right? I think that's what this video will be. It will just be a normal, like Leos Lab style video. It's short, quick, to the point, but it is still a horizontal video. That's my current idea. I could change it to a short if I wanted to. That might be something I'm going to do in the future. But just since we're having this discussion, if you're here watching the YouTube VOD, because I know there's probably a few people watching the VOD right now, and you have like a particular like, you know, you really like shorts or you really don't like shorts or whatever, just let me know in the comment section. I read all the comments that I get. My channel is small enough that I can read all the comments. Right. The only other thing I want to say before continuing is this. Videos. Let me go to my latest videos and let me talk about AI really quick. So this is obviously my worst video I have ever put out. Let's go into popular and let's just scroll all the way down. It is my least popular video I've ever put out, next to introducing the introduction to kernel GPU programming with Julia and an n-body simulation, right? Now, to be honest, these are my two most recent videos, right? And the reason these are underperforming is just because I have not been putting out content in a very long time. I get that. I'm not sitting here pretending that like my most recent videos should be viewed a bunch. In fact, the reason I bring this up is I'm actually quite thrilled with the fact that this got basically 2,000 views. Like, I mean, I don't know. That is way more viewers than I thought I would have gotten on a video like that, right? Because for me in particular, if I see an AI video, I don't click on it. I'm not interested. It's one of those things where like, I genuinely do not want to see more AI content at all, right? And so I'm quite happy that people were, for the most part, engaging with the content. And they were, you know, putting in criticism and also like they were engaging with the content to some extent, which is better than the only other controversial video I put out, which was a video on the Trump administration like 4 months ago. Like that video is, you know, the comment section for that video was downright vitriolic. At least with the most recent video I put out, like the comment section was more or less tame, right? I heard that shorts are valuable in getting people to your channel because when you have short bite-sized points, people consume them quickly. Then they can get an idea if they want to see more. Right. This is also the idea. Like, so I think this is probably what I'm going to do. All right. First of all, journal, new page before. Here is probably the plan. Right. 1, I'm going to put out the video. Put out current video. All right. 2, next video will be in a few months. All right, it's going to take time to make the next video. I want the next video to be good, right? To be really good. And this means I'm going to have to redevelop my engine. I'm going to have to do a lot of stuff, right? There's going to be a lot of things I'm going to have to do, and a lot of that's going to be shown on stream. But probably what I'm going to do is 3, live stream that content, right? I want to live stream as much as possible. And then 4, what I want to do, make shorts as a more or less testing ground for like various effects. Right, so as the engine becomes more capable and I'm able to do more things, I'm going to make short form content, just kind of showcasing what the engine can now do, right? I think that is a good general, like, I think that's a good strategy, right? That way I have the short form content that I'm putting out. I've never used TikTok ever in my life, so I'm not entirely sure if people are even still on that platform. I assume they are. I'm not entirely sure. But my assumption is that, like, you know, there's still a market for people who want this type of content. In fact, like, you know, me in particular, I love short form videos. I'm not short form shorts, but short form videos. I'm a big fan of that type of stuff. Okay, so I think this is where I'm landing, and I think that's a good place to land. Okay, let's get on to the actual content for today, which is doing real animations with my animation engine. So as of yesterday, we did a 5-hour long stream, which is the longest stream I think I've ever done in my entire life. I might have done a longer stream once or twice during my PhD, but I'm not used to these long streams. 2-hour streams are my bread and butter. That's what I'm used to doing. Today, I'm starting at 1 o'clock p.m., which means I can go until 4. I might go until 4, but if I'm being honest, probably not going to go till 4. Probably going until, like, you know, let's say 3 or something like that. It just depends on how things are going, right? Hey, Hanif, how are you in the YouTube chat? Okay, so what I want to say is yesterday was actually broadly successful, right? In terms of putting content out on Twitch. It was probably one of my most successful streams I've had in a very long time. We had an average viewership of 50, which is crazy for someone who's not even affiliated on Twitch, you know? And I'm not saying that I'm hopeful for the future of this channel as a live streaming venue. What I'm trying to say is I'm quite happy with that, and I'm very happy with all the people who tuned in, and I'm very happy with the work that we did that day. I think we got a lot done, considering it was live. We had a lot of really good discussions, and there were a lot of good people having, you know, really meaningful conversation. And I think that's about the best we can hope for a live stream. So let's go ahead and talk about what we did, and then we can move on to what we're going to do today. By the way, Lake, I don't know. Thanks for following. I really appreciate it. Okay, so what did we do yesterday? There were a bunch of little things. So 1, the engine was completely broken. it completely broken. It worked on the CPU, didn't work on the GPU. We fixed that, right? And there's a bunch of different things that were broken. One was that we had this random seg fault, had to deal with MPI nonsense, which we weren't even using MPI, but hey, that's the nature of Julia. We fixed that seg fault. That was number one. Number two, we fixed the random number generation on the GPU. Now, this is a situation where probably people were watching and they're like, hey, why didn't you ask ChatGPT to do this for you? And the answer was, I just don't like using ChatGPT. That's how it is. And we had a huge discussion about AI. We can talk more about AI today, but really, truly, if you want to talk about AI, I want to funnel you to that video that's in the description for my Twitch channel. I don't want to talk too much about it. But what I will say is I really enjoy the process of learning. And even though I didn't really learn too much about random number generation, I feel like that was still a very helpful experience for me. And like I got some intuition I didn't have before. So this is all really good. I'm really happy with that. Once we got the random number generation fixed for the GPU, we then were able to start generating animations. And in particular, let me show you the animation we made. CD projects, fable.jl. Let's see, it's actually up in the upper right hand corner. We're going to do MPV output. Oh, sorry. Where is it? ls? Oh, sorry, it's in another directory. CD Fable Laos, and then Fable. I need to change the names here. And now we're going to do MPV output dot MP4, and we're going to do loop 0. All right, so here's the animation we made. Now, is it a great animation? It's an okay animation. It's the first animation I made with my engine. It's fine. It's okay. Again, the power of this animation engine, the reason I'm so interested in it is that it is essentially memoryless. It's meshless. There is no mesh here, right? It's similar to signed distance fields in if you're used to doing stuff with shader toy and stuff like that, and that like this is all done mathematically, right? And so what we did is we took a single primitive, that is this circle in the center, right? Which is basically a point cloud. It's a bunch of random points, a couple million random points that are kind of stuffed into that random circle, right? We took those points and we distributed them out into the stars. We distributed them out into the ring. We distributed them out into this comet that's going around the star as well. And we did a bunch of things that really showcase the power of this engine as compared to, for example, signed distance field or compared to mesh-based methods, right? For example, compared to mesh-based methods, we were able to change the topology of the circle in order to create this ring system, right? We were also able to do these smear frames really easily for this, this comet that's coming out there. And we were able to do this swirl texture on the inside, not by actually just creating the texture mathematically, but we actually just created like essentially a pizza pie type of situation. And then we use the fact that we're using that, you know, the points are in a point cloud to actually rotate the point cloud in order to create that center vortex, right? This means that we're able to create vortices relatively easily. We're able to create a huge number of points, as in the stars, without allocating any additional memory. We're able to change the topology of our mesh. We're able to do smear frames. This is all stuff that we can do with our engine that are difficult to do in other places. For example, smear frames are particularly difficult to do in 3D engines with meshes and very difficult to do with signed distance fields, because if you want to change the topology of your object that you're creating with the signed distance field, the core problem with that is you're going to have to change how these objects are represented in signed distance field space, which means you also have to usually change how the rays are marching in some non-Euclidean fashion. It becomes a huge pain, right? This is easy, right? And this is kind of the core tenet, something that I really want to hammer home with this particular engine. It is an active research project. A lot of the code is a little bit messy. It's going to be messy. I need a lot more time to develop it, but that's kind of the point of this stream, to go from point A, where we're able to do an animation like this. It took some time. We're working on it, to something that actually looks pretty and engaging, and that I'm hoping that people will enjoy. And I'm hoping that this video that I'm making now will be the first step towards doing that, right? That's my hope, right? Okay, let's go ahead and catch up on chat. It's okay, though, looking in is amazingly efficient at reaching goals. I also used to spend all-nighter to code my project. Yeah, I think there's one thing that I've been realizing recently. So after I put out the AI video, I learned something that I did not really think, I had not thought about before. And let me be very clear about what this thing is that I learned. See, it turns out that there were basically no commenters who were in support of AI. Rather, the commenters who were supportive of AI were arguing that copyright shouldn't exist, right? And this to me kind of blew my mind. It was something that I had not thought about before. Like, yeah, I think everyone acknowledges that AI is a useful tool for very specific cases. But what I did not understand is that the people who are for AI are generally against copyright. Maybe not generally, but there is a large fraction of people who are pro-AI who are also anti-copyright. And that to me completely blew my mind, because to me, okay, I would 100% agree with you in saying that the current IP and copyright laws are flawed in very many ways and can be exploited in a bunch of different ways, but I'm still kind of for the system in general, and I feel like it does make sense moralistically to give people rights over the content that they're making, right? This to me feels like just a baseline level of understanding of why the IP law exists and why it is good to maintain such IP laws. In my case in particular, I think IP laws are great because, I am a content creator. I've been creating content for years, and as a content creator, I don't want to be incentivized to make slop. And if you do not protect people's IP, like if there are no IP regulations, then we run into a situation where content creators are encouraged to create slop. They're encouraged to create reaction content. They're encouraged to mix previous music videos together. They're encouraged to make stuff that is essentially pulling off of other people's IP. But if you have some baseline protections on that IP, now we're in a more level playing field because it means that people can create new original content that isn't necessarily pulling off of anything, necessarily. And then they can go from that and they can build into something that people will watch and will engage with, right? So really the point of IP in my mind is not necessarily so much for monetary gain or anything like that. It's to ensure that everybody has an even playing field for if they do want to create original content. There should be at least some way for that content to succeed on the platform. And if we do not protect IP, unfortunately, we run into a situation where everything turns into gaming, right? Like this is exactly what happened on YouTube, right? It used to be back in the day that it was kind of 50-50 as to whether you could play games on YouTube, right? Because it wasn't very clear as to whether this was or was not violating copyright. And then most people agreed, yeah, you're probably violating copyright, but the game publishers like it. And because the game publishers liked it, now you have all this gaming, essentially slop on YouTube. I mean, I'm not saying it's like, it's just like Let's Plays and stuff like this. Now, a lot of people really love that content, and that's great. But it is quite different than someone, creating their own music video and editing the music video and creating their own music and stuff like this. You know what I'm saying? One, you're engaging with content that already existed, and another, you are fundamentally creating something new from the ground up, right? And all I'm saying is that IP laws allow for that fundamental creation more than the IP. And pulling off of IP, right? Now you'll notice that I'm very sticky when it comes to IP. I've always been very sticky when it comes to IP. This is something that most other content creators are not this sticky, But for me, I care a lot about copyright. I've always cared a lot about copyright. And so I'm going to be more on the side of, yeah, probably I'm not going to be playing games on streams, or probably I'm not going to be showing articles. I might every now and again, but I try not to unless I have something important to say about them. This is kind of stuff where it's I feel like I'm on the side of I would like everything that I put out here to be more or less at least to be legally okay. There's no gray. It's this is all good, right? So for example, the music I'm listening to right now is via Josh Woodward, who has everything in Creative Commons as long as it's attributing them, and I do attribute them, and this is the type of stuff that's yeah, you always draw the line in the sand, just after, the stuff that you do. I understand that maybe the stuff that I do is still morally gray from some perspective, but it cannot be argued that the content that I've been putting out, this is genuinely my own content and not something pulled from other people's IP. Everything that I've shown, sure, maybe I've learned stuff from textbooks or something like that, but everything is mine. And there are very few content creators who go from literally the ground up, and I can say that, yeah, this animation engine is fundamentally a new research. I'm not even using Godot or something like that. This is fundamentally mine. Everything is fundamentally mine. It's very rare to see someone to be able to go from literally nothing to where we are, to be able to create animations and tell interesting stories without having to rely on anybody else for that. And this is kind of part of what I'm doing. Anyway, that was a huge ramble, and I feel like I'm moralistically grandstanding. I'm not trying to do that. I'm not trying to sit here and say, oh, I'm better than people because I'm not using other people's IP. That's not what I mean. I just mean that for me, that's always been a goal, and it's not a goal for other people, as much. What do we have here? Apparently, leadership of some AI companies think the same, at least in terms of being able to use IP. Yeah, I think this is the thing that always bugs me. You cannot claim that you own the copyright from AI. It's a false statement. That is downright a false statement. You can, lie to your audience, which is what OpenAI is doing, but that only makes me not want to use their system more because now I know they're lying, right? Okay, let me go ahead and catch up on YouTube chat as well. Let's see. In my observation, the pro AI are overwhelmingly hate artists. They love the sight of artists failing. Really? I hadn't seen that much. I think AI people generally, there's probably some people who are very much pro AI and probably also hate artists because they feel like artists are snobby. It's the same with academics. People feel academics are snobby because they have this niche knowledge that no one else has, and they're able to do stuff that no one else can do because they've been training their entire life to do that. It's the same with artists, right? They've been training their entire life to be able to sculpt this thing, to paint this thing, to animate this. It takes time and effort, right? And if you have not put in the time and effort, it feels like kind of annoying that these people are able to do stuff that you can't do, right? I get that, like from a fundamental perspective, right? However, usually the academics that I know, the people who are pushing the boundary of human knowledge, at least to other academics, are downright humble. They're never the people who are like saying they're better than other people. No one makes that claim if they are academics. It's always the non-academics who are claiming that academics think they're better than them, right? And so there's always this kind of like this I don't know how to put it, but this disconnect between people who can do things and people who can't do things, and it always feels like that disconnect leads, like. The thing about AI is it does genuinely lower the barrier for entry in a lot of fields. I'm not arguing that. No one's arguing that. Like, you can now do programming where you couldn't do it before. That's what vibe coding is. You can now do art when you couldn't do art before. That's what, Midjourney allows you to do. The arguments that I'm making as a professional, as a researcher, is that like we have to be very careful to make sure that the learning still happens and that we're not overly relying on these tools, because if that learning doesn't happen, then we run into a situation where no one can go from that 70% that AI brings you to that actual 100% of the finished product that you want to make, right? And it's just like, I don't know. I said I didn't want to argue about AI. I don't want to argue about AI. I think we should probably like take a step back from this conversation. They hail AI as the ultimate artist crushing machine. Guess I'm the rare anti-copyright and anti-AI. So I do like, for the record, when I was saying like, when I was arguing about anti-copyright, I think I am starting to understand the anti-copyright folks. I think I'm understanding it a bit. They're saying that like, IP, like if you draw Mickey Mouse, like Mickey Mouse is not like a physical object that you can hold, right? So it's not the same as like owning a rock. You know what I mean? So why do you have rights over Mickey Mouse more than you have rights over your own home? You know what I mean? Like, it's this type of thing. I guess I'm understanding that from some, vague point of view. I just see it as such a net win, IP, for everyone involved, including the content creators, actually, especially the content creators, that like I just don't really see it a reason as to why we should like completely throw out the system, right? The irony of having open in the name OpenAI. Hi from Klungo. Hello, Klungo. How are you, Klungo? I hope you're doing you're having a great time. I don't know. Okay, so let's get to work. Like I said, the plan is to, one, put out the current video. It's going to be 2.5 minutes of me just talking about the animation engine, why it's interesting and stuff like that. What I'm going to do now is I'm actually going to go through and I'm going to storyboard that animation and figure out what we want to do, what animations we're going to need, and which ones are going to be challenging, okay? I already have the storyboard available. Like, I already wrote it out on my notebook. I just have to kind of like sketch it in front of you guys and explain like what the plan is. So it is right here. There we go. Maybe I should just take a photo of it and just leave it there. And then after we do the storyboarding, we're going to talk about which animations are difficult and which ones we should target first. But in all honesty, if we really do want to get this done, I could probably get it done by the end of the week. I think I can get it done by the end of the week. Pretty sure I can get it done by the end of the week. We'll see. Okay. But the good news is that the core advantage of this method is that we are able to like more easily do like these kind of like weird wobbly smear framey effects, which I'm really going to be heavily relying on for this particular animation. Good. So this is kind of the whole. Let me just kind of go through the entire video, right? It's just a 2.5 minute video. Here's what I say. I basically say that. One second. I basically say, like, I'm like this visualization of a planet. With the stars and the rings and the comet and all this kind of stuff. And every time I say like stars, I want the stars to shimmer and I want the rings to move and all this kind of stuff. It's going to be easy to animate that. Is itself a fractal, right? And this idea that this is a fractal is hopefully going to be the thing that gets people encouraged to click. Like, yeah, I want the video to look like this, just be a screenshot of this and just to say, this is a fractal, right? That's it. That's the video title and everything. Then I go into it and I say, okay, kind of, right? And the reason it's kind of a fractal is because essentially this circle in here is the initial fractal, right? What we've done is we've taken a single point, we've passed it through an iterative function system, and after passing it through that iterative function system, we create the circle. Now, does that make it a fractal? The answer is yes, because all the output from iterative function systems are fractals, so it's a fractal in the same way as a triangle or square or any of these other kind of like non-interesting objects are fractals. But in particular, the reason this is super fractally is because it was generated from an iterative function system, right? I could have done any generator, but this one specifically was from a fractal generator, right? And then I go through and I explain exactly what I said before. Like we take this object and we can create a whole bunch of different objects from it. And then by creating these different objects, we are able to, we can take this object primitive and turn it into any number of other objects, right? And then I talk about how that process happens and all of that. So for the most part, I think this animation is a big one. But then we have a couple other things that we have to animate. The first of which is we have to draw a circle. And we're going to have to split a circle in two. This is not going to be super difficult to do. Top half and a bottom half. And we have to explain the iterative function system. There's function 1 and function 2. All these do is they take the circle and they find a way to push it all up into either the top half for function 1 or the bottom half for function 2. Now, if you're wondering how this happens, it's actually kind of interesting. What we do is we take essentially a single point, and this will have some radius and some theta, right? And what we do is we say, okay, let's just swap the radius and theta, right? Radius and theta. And what this will allow us to do is give us a theta that ranges from essentially 0 to 1 or 0 to r, right? And we can scale that. So instead from 0 to r, it goes to 0 to pi. And this will give us an angle, right? And we take that theta, that's, again, from 0 to 2 pi, and we scale that down to r, right? So essentially all we're doing is we're swapping the r and theta. And then what we say is, okay, now we have two functions. Function 1 essentially goes from 0 to pi, and function 2 goes from pi to 2 pi. And that's really all we do. Well, all we do is we swap theta and r, and then we force one half to go to the top half, and the other half, to force one set of points to go up, and the other set of points to go down. And that's it. That's all the function system is. Actually, I was very interested in this function system because there's another video I put out on Leos Labs Live like 3 years ago now, talking about the generation of this circle, right? Because it's actually quite trivial to generate a function system for squares and for triangles, right? And specifically for the Sierpinski triangle, right? The Sierpinski triangle is literally just F1, F1. Oh, let me just show it to you on the algorithm archive. Algorithm archive. Come on. Go rhythm. Stop! algorithmarchive.org. There we go. I'm really struggling today. So for iterative function systems, the Sierpinski triangle is literally just p plus a over 2, p plus b over 2, and p plus c over 2. So literally all it's doing is taking your points in space and moving them halfway towards a, b, and c. For the square, it's literally the same thing. We just add an additional function in here. For the triangle, things like for the filled-in triangle, things are a little bit more interesting because not only do you need the functions that bring you halfway towards A, B, and C, but you need another function that will flip and create the triangle in the center. And once you create that fourth function to fill in the center of the triangle, okay, now you have 4 functions that create a full-in triangle, right? And so again, square, triangle, these are easy to do, but circle was actually quite hard for me to do. I couldn't come up with an iterative function system to create a circle. And the creation of that iterative function system, like learning how to do that, gave me some key intuition as to how to create iterative function systems in the future that I would not have known otherwise. And that was, I'm actually very happy that we were able to create that, right? But still, the whole point of this system, right, the whole point of my method is to hopefully make it so that people can mathematically represent scenes in a way that they couldn't do before, right? And so where sign distance fields are kind of unintuitive, my hope is that this engine is intuitive, right? And so unfortunately, no matter what I do, iterative function systems are just not going to be intuitive, which is why I'm focusing more on like the general purpose nature. And in the next incarnation of Fable.jl, my hope is that I'm not really focusing so much on the generation of the object primitive. We have multiple generators available. Instead, I'm focusing on how to take that object primitive and turn it into something more engaging. Okay, good. Let's talk about things that we need. So journal, new page before. I was going to storyboard everything, but I also have the storyboard ready. And I'm wondering if maybe it's actually just more engaging just to start doing the animation. I think that's what I want to do. I think I'm just going to start doing the animation. But there's one thing I want to do first. There's one thing I want to do first, and you guys are going to maybe hate this thing. I have a child. You know these little stupid... these stupid slap bracelets, does anybody know these? I had completely forgotten they existed, right? But then all of a sudden my kid got one. I'm like, man, oh. I was transported back, 1992 when I was born, and yeah, it's just, somehow the toys are like exactly the same as they used to be, Like, and that's great. I mean, like, because I do understand that, like, oh, there's AI now, there's phones now, all this kind of stuff. But, it's like, you use them as reflectors for biking. That's actually very interesting and a very good usage of them, you think. Because you probably just put them on your ankle, too. And then that really helps people see them pretty well. That's actually really nice. I like that idea. It's better than TikTok brain rot. So to be fair, my child does watch a video every now and again. He's 2.5 years old now, almost 3, and I think it's okay to start engaging him with other types of content. And so like we'll watch some. So he speaks 4 languages, right? He speaks English and Catalan. Those are his first 2 languages, and then Japanese and Spanish, right? In that order. Japanese is still very good, but it's not where we want it to be. So we'll sometimes put on Japanese videos to get him to like get more interested in it. There's one like synapse in Japanese, and he really likes this one. Unfortunately, he also saw a video of Teletubbies, and he's really into Teletubbies right now. But obviously, look, I'm not sitting here saying like I'm morally justified in doing this. I understand he should not be watching videos, but he's also almost 3, and I think showing him a phone nowadays it's kind of fair. You know what I mean? Because he will probably be engaging with them in the near future. Near being a couple years, and like, we waited for 2 years to let him watch videos. So I don't know. I think it's fine, but you guys can go ahead and say I'm moralistically wrong for allowing my child to watch videos, whatever. I also accept that probably it's not the best thing in the world, but still, it's good to kind of teach him things that we like. How do I put this? It's good to teach him like languages and things that like show him that there are other people speaking Japanese. Is kind of the thing, like that's the thing. Let's see, French is at least better than brain rot. Last time I had one was probably 15 years ago. I had a watch with that band as a kid. My family have a policy of no phone until 18. We do have laptop though. The ideas phone interface are dumbed down, while proper PC interface are not. To be fair, I did not, like this phone that I have right now, I have a Samsung Galaxy S24 Ultra. Do you want to know the first smartphone I ever bought? Let me just explain this to you. So this is a Samsung Galaxy S24 Ultra. Let me just write that down. I bought it. Do you want to know why I bought it? Because it can run OpenCL, and I was writing my code in C at the time, and I wanted to be able to write my code and run it on my phone. Do you want to know the first smartphone I ever bought? It was a Samsung Galaxy S24 Ultra. This is the first smartphone I have ever bought. I did technically own another smartphone, but I stole it from my dead grandfather. I don't know how to say that in a way that sounds good. So I never bought a smartphone before this. This is the first time. And before this, I had a LG Lotus. I loved the LG Lotus. Man, no one knows about this phone, but it was the best. LG Lotus phone. It genuinely the best phone. Like, I still wish I had this phone. Okay, mine was black, not pink, purple, but it was such a good phone. Like, you have a full QWERTY keyboard in like this old school case. You could open it up. I still want this phone as a pocket terminal. Like, I want to be able to have this phone in my hand so I can do like, this is the one I had right here. So that I can do like, I can just like use it as a terminal. Like, it's such a great little device that I wish I still had. That's what I want. To this day, I have a dream of buying a new LG Lotus and like just revamping it with modern technology, finding a way to like put new devices inside of it so I can just have a pocket terminal. I've always wanted one, right? Let's see. It's tough because sometimes you, the parent, need to break. So having a video just that makes them content is great. Inherited. I think inherited is probably the word I should have said, not stolen from my dead grandfather. Stole from dead grandfather does say something. Sounds like you went through with grandfather. Oh no. No, that's not what happened. Oh my goodness. Let's see. Catalan, is that part of Spain? Maybe a state that is part of Spain? Let's not get into that. My mom told me of a college graduate who can't operate PC, only phone. I remember that old BlackBerry phone. The keyboard gave me nostalgia. Man, I just wish more phones like this existed. That's what I want. I just hopped on, installed the phone, heard Pocket Terminal. No idea if you've seen the Nokia N900. Nokia N900. Nokia's dead, right? Like, it doesn't exist anymore. Oh boy. Man, this is what I want. I want to be able to just have a cell phone. I want a cell phone. Like, this cell phone, you want to know what I use this cell phone for? 90% of the time, this is what I'm doing. I'm here. I'm on Termux. That is what I'm doing 90%. Does this give any information out? No, it doesn't. I'm on Termux. That is 90% of the time what I'm doing. Like, if I'm on Termux 90% of the time, just SSH onto something and coding. Like, all I want is a pocket terminal. That's it. That's what I want. You know what I mean? And like, we don't have keyboards anymore. I don't know. I know I'm old. Like, I'm using VI without syntax highlighting. I am old. I get it. You guys don't have to drill that into me. I understand I'm old. Like, I'm even older than my age. You know what I mean? But even so, a pocket terminal is just something I've always wanted in my life. Like, you know, I was born and the next day I asked for a pocket terminal. I know I did. I'm sure I wasn't speaking English, but I'm pretty sure I said that's what I wanted. I remember it clearly. I hopped on, I had this for years. It runs actually Linux. Hackberry U console. Let me look at that. Let's see. You're in your mental prime. Preach the good life. Do you also have a wireless keyboard hooked to it for typing easier? Oh, no. See, look. You, my friend, do not understand. You don't understand. You don't understand. How do you not understand? Do you guys just not know who I am? You guys must not. It's been a while since I used this interface. It has been a while, but it does work. Oops. 1 second. Let me see if I can find it. Oh, where is it? Oh, did I lose it? Are you kidding me? No, I couldn't have lost it. I must have put it somewhere weird. No. I actually have a clamp. I have a clamp that I attach to my physical keyboard that I'm using right now, and then I attach that via USB to my phone. I'm using a mechanical keyboard to type onto my phone. That's what I do. That is when I actually was programming on my phone. That's what I did. How did I lose it? Are you kidding me? Oh my goodness. Oh geez, I'm disappointed. I did this months ago, and I can't find the clamp anymore. Yeah, so I would literally go around with my mechanical keyboard and phone. I have a special case for it even. Where my kid was playing with it. Is it in the case? No, it's not in the case anymore. But I carry the case around with my keyboard and this like clamp, basically, that I kind of MacGyvered onto the keyboard, and then I just type. That's what I do. That's how I do it. And it was great. It was the most, to me, like I don't need a laptop anymore if I could just use my my phone for that. Now, one thing that I want to say though is that unfortunately, if I keep using Julia, I can't keep using that setup because Julia does not allow for Android. Like, it's not as, it's not. I can use OpenCL on my phone. I cannot use Julia on my phone easily. I can, but it takes me some workarounds, right? Do you also have wireless keyboard? There is Pro 1X phones, small company, but as far as I know, they are still making the phones. I mean, maybe I should look into this. Typing a lot on touchscreen unfortunately sucks. So what is your setup for the terminal access using phone to connect back to your home lab? What's your setup for the terminal access using phone to connect back? I just use... I mean, I bought the S24 Ultra because it's stronger than my old laptop, so I just use the GPU on that for OpenCL. But because I've swapped from OpenCL, I don't use it as much anymore. Sensing a lot of words indicating that you, sir, venture into meat space. What is meat space? I don't know what meat space is. Oh, Tommy Two Toes. I just realized it's Tommy Two Toes. Hey, how are you? I'm interested to see the computer graphics research. We're working on that. Give me a second. I'm getting there. Okay, just give me a second. Okay, yeah. Give me a second. I'm getting there. Meat space is the alternative to cyberspace, where humans live. Oh, all right. Let me go catch up on chat. We'll get into the actual research stuff. My mom told me, why not a netbook? Do netbooks have access to the internet wherever you go? Do they have a data plan? They might have a data plan. Half of my family is from the Basque Country. They hate my dad because I wasn't taught Euskera and that I like Spain. Okay, yeah, I don't want to go into this discussion so much about like whether Catalonia is or is not part of Spain. Let's not have this discussion. I don't want that discussion. Also, Clicks keyboard. Oh, I think I saw this one before. I'd been looking into something like this, and I just didn't really. Oh man, I was looking at this, so I feel like I kind of want this though. I do kind of want this. The problem is that my phone is giant. My phone is already so big it barely fits into my pocket, and I have like, you know, men's shorts on. You know what I mean? Like this is like, it doesn't fit in my pocket already, so I don't know what to do. So I can't, this looks like it's not going to work for my specific use case. Do you own a Raspberry Pi? I do not, but we used to code them a lot when we taught Scratch for, Oist. Switch to cargo pants. I am wearing cargo pants. Do you think I'm not wearing cargo pants? I think you guys don't understand how big this phone is. Like, here's the phone. Here's my hand. It's bigger than my hand. You know? Like, it's a giant phone. I bought it because I wanted the screen real estate so that like, how do I put this? I bought it for the screen real estate because I wanted to do programming on it. but it's actually giant. It's huge. It's like the phone is crazy, you know? Like, anyway, it's annoying that each generation seems to get bigger. Yeah, I did want the big phone though. I really did, because I was going to do, it's my laptop now, right? And so if it's my laptop, I do want something that has a decent amount of screen real estate. Also, I have to be honest, cargo pants work better if you're a bigger person. How do I put this? Like somehow the size of your pockets increase with the size of your waist. I'm not saying I'm like particularly small, but I'm not like, you know, I'm not particularly big either, but unfortunately, like, just the pants pocket sizes that I have are not as big as other people's pants pocket sizes, is what I'm trying to say. And so I have the situation where, like, yeah, maybe I should just wear bigger pants, like a bigger size, but then they, anyway, I don't want to get into this. This is another discussion that's kind of too embarrassing to talk about on stream. Okay, look, one thing that we did not fix yesterday, let's go back to that. One thing that we saw was an issue yesterday that I did not fix was that video output was broken. I want to fix that right now. That you can't read that because let me just move this up. So let's fix the video output issue number 1. That's what we're gonna do now. And then we're gonna start actually doing like animations with it. And then after we do the animations, I want to get at least the first like 5 seconds of the video done. I think we can do that pretty easily in like an hour, I think. I say that knowing that every time I say we can do something in an hour, it takes like 10 hours, but I really do. I genuinely believe we can get it done in an hour. Because what I've learned is something, see, this is not true for most programmers. I'm gonna say something like that, how do I put this? So I have a friend, okay? Most people, you know how I'm really good at telling stories? Okay, I've got a friend. He was doing the PhD at the same time I was doing the PhD, right? He had a really, really tough thesis writing period where I had a really easy thesis writing period. I just stapled a couple of papers together and I said, I'm done. But he wanted to do something more with his thesis, and that's fine. Everyone has the right to do something more. He and I would work out every day. So I'd go to his place at 7 in the morning after stream, and we'd go to the gym. We did this every single morning. And every single morning, he'd complain about his thesis. And in particular, he'd say the phrase, I hate myself. Journal, new page before. I hate myself. That's what he would say. I hate myself. Now, here's the thing. When you're a PhD student, in general, you do hate yourself. Like, there's you have to be a little bit, I don't know how to put it, but like, just, you have to hate yourself a little bit to finish the PhD. Like, that's just how you have to get through it. There's no other way around it. But in particular, he hated his past self, right? Because his past self was so focused on writing very clever code that he could not understand it as his future self. You know what I mean? Because he had to look at this code that he wrote 4 years ago for some old project, and he had to somehow decipher it in such a way that he could now use it for new stuff, and like write it into his thesis, right? But he couldn't figure it out because his past self was so focused on writing this clever MATLAB code that he had no idea. Like, he could not figure out what he was actually trying to do. Now, here's why the story is interesting. Because actually, I found myself in the very same situation. I've not really been writing this code base for like the better part of a year, maybe 2 years, right? And it's been working for that time. I just didn't know what I was doing. Now, I actually looked at my old code, right? And I realized something. Like, this is one time I don't hate myself. I usually hate myself. But actually, old me was a pro. Way better than me. Like, I don't know why, but old me was like just a boss. He was really good at programming. Me, I don't know what I'm doing. But old me, man, he documented the crap out of this code base. To the point that, like, this video error issue, I think I already have an issue for the video issue. Let me just go here to github.com. And let me go to Fable. Where's Fable? Here it is. And let me go to issues. I think I already have an issue up for this specific case. Let me just look for video. And default video output creates artifacts and on colored output. There we go. Look at that. Look at that. So, for example, if you color the ball, in the smear example, you get 2 balls, one here. This is the exact issue we had yesterday. And this is where I'm like, man, like, I don't know why past me was pro, but like, and current me is an idiot. But like, I think we've already made some headway to solving this issue. So let's go ahead and describe what the issue is. So first, let me go and generate, let me do fix AMD. Sorry, it's fix AMD GPU. There we go. And I'm going to run Julia, --project, T12. All right. And I'm going to show you the current issue. So now the first thing I'm going to do is using revise. And then using, what am I doing? Fable intro. And then using AMD GPU. All right. Give that guy a go. Programming, we all know you just want to see Candy Crush. What's easier, buying bigger pants and having them and having them hemmed in, or buying regular pants and swapping the pocket layer. Yeah, I don't know. I don't know. Let me do Fable intro, space example for 2 seconds. So here is what I was running before. Let me run an AMD GPU.atTime. All right. And we'll just see how long this takes. Now, remember, this is also incorporating precompile time. So we have to take that into account. But overall, it takes like 6 seconds to run, right? Ideally, we'd be able to turn this into a video, and if we were to turn it into a video directly instead of outputting a bunch of PNG images, it'd be a lot faster. Unfortunately, I couldn't do that because of this video codec issue, but I solved the video codec issue sometime in the past, and I trust past me to have known what he was doing. So, let me catch up on chat. All code, no comments. We never write code at the edge of your ability to write. It will be beyond your ability to debug. That's a very, very fair statement. Looking at old code is risky. It's kind of interesting that past you is 2023, and I remember past you as 2017. That was a wild time. Yeah, to be fair, you have been here. I think you were one of the first people to watch my content. Like, genuinely speaking, I remember your name as I think being like within the first week of me actually making content on Twitch. Like somehow, maybe first month or something, but definitely, I remember your name from back in the day. What a long time. Like, what a long time. Tony the Tinkerer, thank you so much for following. Really appreciate it. Just fix AMD GPU, set up some environmental variables. It sets up some environmental variables because otherwise we have an issue with just MPI. I don't know. It's some weird bug that I don't know how to fix it. Sorry. No, I really appreciate you being here. Do you Raspberry Pi? I own a Pixel 9, but I'm running Graphene OS. Okay, I've thought about doing something like that to my phone, but I haven't thought about rooting it or anything like that. Is the problem GPU specific or CPU2? I mean the video issue. So the video issue is codec issue, so the CPU will also have the similar issue. So here's what I'm going to do next. I'm going to open up a new terminal because again, in life, whenever you have a problem, there's always one solution, and that solution is to open up another terminal. I don't care who you are. I don't care what the problem is. The solution is always to open up another terminal. Always. That is always the solution. And the first thing you do is run this command. And then when you watch the train going across the screen, you realize that really everything you're doing in life is kind of pointless. And you should probably stop doing the thing that you were going to be doing. But regardless, even if it is pointless, we're going to continue. So let me do cd projects, Fable, Laos. Fable layout? iOS. CD Fable intro. L is here. And let's go ahead and comment in everything that we're doing for video encoding. So let's go into VI source here, and let's just do video. So I commented this out, but we did have this working yesterday. So file name is going to be equal to, and we're just going to call it output.mp4. Just for now. Output.mp4. And then we're going to uncomment everything else for videos. Write video. Close video. And in principle, as long as we comment out the right image, we should be able to write to video right now. Let's try that again. So the last time took 11 seconds, and some of that is because it's taking time to stream. This one has to precompile. Should be much faster. Usually it's a lot faster. Okay, it's actually quite slow, isn't it? I thought it'd be a lot faster than this. 11, let me try that again. Because it should be faster. It should be faster. I just overwrote my output file. And that means that your video up there in the upper corner is going to be, anyway, output.mp4. So anyway, here's our video now. There's our video. Look at that wonder. I don't know why this happened. I don't know how to fix it. I'm going to look at the old issue and see if we can fix it. Now, was it actually faster to output to video versus outputting to image? Let me see. It took 9 seconds to output to video, and it took how long to write to image? Let's check. Why did it take so long? I don't understand why it took so long. Usually it's quite a lot faster to write to video. Did I do something stupid? I must have done something stupid. Let me open up a new terminal and see why it's taking so long. All right, we're cd into projects, fable.jl, vi examples, smear. Why does it take so long? That's insane that it takes so long. Usually the output step is what, let me try something really quick. Let me see how long this write video command takes at time. And then we're also going to at time each of these guys. All right. Oh, that was not what I meant to do. Sometimes you fail at life, and this is a situation where I just kind of failed. That's okay. It's okay to fail. Okay, so we're going to put out a bunch of timings. Let's see what happens if we run this one more time. And we're going to run AMD GPU at time. You broke. Why did you break? That's a good question. Let's go here, there, and there. And why did it break? Is it multi-threaded or singular? It is multi-threaded, but it's on the GPU, so it's by default multi-threaded, right? Because it's GPU, you know, it's GPU. Okay, I had thought when I went into this stream that encoding to video was so dramatically faster than encoding to images, because that's how it has been in the past. But now I'm curious as to why it seems to be about the same runtime overall, which is very curious to me. Now this completely broke, so let me just run revise.retry. And it says, oh, AMD is not defined, so let me just go up here and do using AMD GPU for now. Oh, I have to add AMD. Oh, okay, screw it. I'm not adding AMD GPU. I'm switching all the AMD GPU tags to just at time in general. And we're just going to... The difference between AMD GPU at time and normal at time is just that we're focusing on... how do I put this? Wait, where's all my time going? Wait. What's going on here? All right, wait. Let me take a look at these timings. So it looks to me like writing to video in this case took... Let me try that again. Let me just do one thing though. I'm gonna do print line, video time, dot. Just so I know which one's the video timing and which one's not. Then I'm gonna do another print line after this, just to add an extra new line, just for fun, because who doesn't like new lines? Everybody likes new lines. All right, right here, try it one more time. Okay, video is images when there is no sound. This is true, but the difference is that I don't have to output to a PNG image. What I can do is I can immediately write to the MP4 file, and by immediately writing to the MP4 file, you get a, like you don't have to compress to PNG. There's different, like the compression's a bit faster is usually what happens. So video timing, okay, I see. So the time it took to write the video was 0.2 seconds, which was the majority of the runtime for each, right, for each step, I think. Let me just go ahead and put this into a big block. And let me just do at time begin and at time end in here. And then let me just do this guy down here and there. And let me try this. Video timing. Right. Okay. So the majority of the time is that output time, which is what I expected. Yeah, exactly what I expected. Yeah, this is what I wanted. Yeah, so see how the time it took to write to video was 1.4 seconds? No, that can't be true. Is that true? No way, I don't believe that. So the timing of each kernel, this is just the timing of the kernel launch. It must be. Let me do, no way that's true, right? There's no way that's true. There's no way each kernel runs in 0.00004 seconds. No way. That is insanely fast. That means you're getting a frames per second of, what's this divided by 1? Of 20,000? We're not getting a 20,000 frame per second. We're not getting a 20,000 frames per second on this. We're not getting that. But it is very weird. I don't understand how we're getting this time. See, so this is the time it takes to do the video. And this is the entire while loop. This is the entire while loop. The entire block is 0.1424 seconds, right? If we multiply 0.14 times 60, which is the number of frames we're generating here, we get 8.4 seconds. Keep in mind, it's actually 0.14. Let's do 14 as an average. Let's do 145, and that gives us 8.7. Why? Oh, because some of them are 0.2. So I don't know the actual average timings here. That's insane. There's no way that's true. I'm doing something wrong with the timing. Are you writing the images into RAM first, or GPU, or directly to storage media? See, so what I'm doing right now is I create a video buffer, which has both a GPU and a CPU buffer. And so what I do is I write to the GPU frame, because that's the image layer, and then I take the GPU and pass it to the CPU. So the majority of the time is being spent in that CPU-GPU transfer, I think, and that's what's taking so long. So this is why doing something like Vulkan or SPURV would enable this to be a lot faster, because I could just directly output to screen and the frame buffer there. I don't believe these timings. There's something fishy going on here. So what I'm going to do is I'm actually going to add AMD GPU to the package. Just... Why? 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 Why did you segfault? What was this about? Why did you segfault? Wow, okay, it's fine, it's fine. Let me catch up on chat while we're thinking about this. 0.1 seconds still seems too long. Well, to be fair, there's a lot of other stuff going on here. So for the record, right, the way I'm storing this data is incredibly inefficient. I made the claim that the only thing I'm storing is the output image. That is true, but remember it's uncompressed, and I'm also storing 4 different layers, R, G, B, and A, all of which are stored as float32 values. Is that the right way to do this? No, the reason I'm doing this is because specifically the AMD GPU package, oh, this shows you how much development time I spent on this package. Specifically, the AMD GPU package has trouble with, oh, no, actually all GPU vendors have trouble with fixed point precision. Now, what's fixed point precision, you might ask? It's a different representation for colors. So if I go into Julia here and I do using colors, I do RGB of 111, right? This is by default. RGBA. There we go. By default, float 64 because I put a dot there. But if you don't put the dot there, it's by default NOF8, which is a fixed point precision number that allows you to hold more data technically with that. I don't really want to go into this. The point is, it's kind of difficult to do fixed point arithmetic on the GPU. So my solution to that was forcing all RGBA values to be float32, which is fine, but that also means that I have to keep around basically 4 different float32 values for all the colored arrays. And then this particular version of Fable also keeps around point values for an additional 2 float64 values. I don't need to keep the points around, I just do because I'm stupid, right? And so there's actually a lot of additional GPU data that I don't need, and I could compress that down a lot more. And that compression would make it so this time of CPU GPU transfer is a lot lower. I just haven't done that yet because I'm what some might call an idiot and others might call Dr. James Schloss. So let me catch up on chat. 0.1 seconds still seems too long. Not sure about the Julia abstractions, but usually starting a GPU kernel is quick, but it doesn't include waiting for the roll. Exactly, that's what I was afraid of with the timings there. So that's why I usually do AMD GPU.atTime, because that usually does wait for the result. It's not just the launch, it's also the run. But I can also do an @synchronize. A kernel abstractions .@synchronize afterwards would allow me to make sure that I'm timing and synchronizing the block and all that. So I can double check and make sure that's okay. But the thing that was interesting about these results, and the reason why I might actually trust them, is because the video timing here is the thing that took the time, which is all in the CPU, by the way. But anyway, the time it took to write each frame in the video took 0.14 seconds, and the entire while loop took 0.1424 seconds. Although it could be true that the time here, some of that time was waiting for these results to finish. That could have been what's happening. It's just, let me do a kernel abstractions @synchronize and then time a block, and let me just see what happens there. Okay, let me go ahead and catch up on YouTube chat too. Hello, YouTube. For animations, it's better to render as images, so if a crash is interrupted, it can continue after restarted. Is the fast time only counting job submission? Right, that's what I'm afraid of. That's what I'm checking right now. I'm the video issue. Yeah, there's no way we're at 20,000 frames per second. That's just not happening, right? I have done the timing correctly, and I've gotten up to 5,000 frames per second for very simple images. But 20,000 is not happening. That's not happening. Okay, also, I don't know what happened with the seg fault. What was the seg fault about? It was about invalid permissions for mapped object address. I'm still getting UCS issues. No, I fixed that. That's what the whole fix AMD GPU thing does. All right, let me do this. Let me just run fix AMD GPU again. Hopefully it works. All right, let's run this again. And this time what I'm going to do is I'm going to do using revise. And I'm just going to time each block. And I'm also going to use kernel abstractions @synchronize, which should force everything to finish before starting the next kernel. And so that's what I'm going to try to do. So we're going to do using Fable images, Fable intro, whatever, I don't care. I don't remember what I called it. My goodness. Again, guys, if you have any comments, questions, concerns, ideas, anything like that, feel free to let me know, and I'll totally address it as soon as I see it in chat. By the way, I have to say this. Thank you guys so much for being here. I really do appreciate you guys being here. It's a lot of energy. Like it gives me a lot of energy. I'm really happy to have the chat here. I'm really happy to have you guys here. It's nice to be able to come back to stream after like just not streaming for so long, and just to have people watching. You know what I mean? Like I've been in and out of the streaming game for years, a decade now at this point. You know, like I'm very happy that anybody at all is here. You know what I mean? And I just want to say that I'm very happy you're here. That's it. So that when I get a seg fault, I can at least jump back from it, you know? right, so now what I want to do is go back over here, and I want to do using kernel abstractions. All right, and let's just time with a kernel abstractions at synchronize. I think it's at synchronize. Well, let's just see what happens. So at time, and what I want to do is at time begin. Oops. Well, I'm an idiot. That's okay. It's okay to be stupid. And then I want to do kernel abstractions dot at synchronize. I believe that'll work. And then we're going to do add kernel abstractions. There we go. And this should give us some better timings. I'm going to see if it gives us better timings. If it doesn't, I'm going to do an AMD GPU.atTime instead of just a normal at-time. So let's just go ahead and give it a go. And this time I'm going to run quite a lot fewer frames. I'm not going to run as many frames as before. So we're going to do Fable intro, rock array, and I'm going to do end time 0.2. Just like 5 frames or something like this. I don't remember how many. But it should be way, way fewer frames. Okay, where's the rock array defined? Oh, using, first let's do revised at retry, see where things are broken. It's saying things are broken because kernel abstractions not defined in, what? Line 346, 346. I am using kernel abstractions though. Like, you know? All right. Outside kernel scope not captured. So is it just synchronized? Method error, no message synchronized exists. 1 second, what is it again? It must be synchronized. I thought it was synchronized. Is it just synchronized? Synchronize CPU. So you specifically need to synchronize. Oh, you have to synchronize on the back end. That's what you got to do. Right. So I want to synchronize and I want to get back end and then synchronize on that specific back end. Right. That's what I want to do. So synchronize on get back end of array type of this, I guess is what I want to do. What an annoying call that is. Also, why is kernel abstractions not, it's also just normal synchronized, that's fine. But why am I not able to use the kernel abstractions dot thing in here? Using kernel abstractions, and let's just go back over here. I can't use kernel abstractions there. So let me do st, see if it's in the state. It is in the state. Let me just do Control D and try this again using revise and then using Fable intro and give that guy one more go. One more go. Okay, that did seem to work. So now we're going to use Fable intro for 0.2 seconds. Rock array not defined in main. That's because I have to do using AMD GPU. I think this is going to work. I hope it's going to work. Let's see. What's the worst that could happen? I'm already an idiot. I can't dig any further than this. All right, so now we're going to do that. Is the fast time, okay, drum roll, 0.6, that's 2 pi. This is, I was basically just outputting the angle at which the comet is. And you broke because I think still the kernel abstractions nonsense, right? Rock array only supports is-bits type. Okay, that's fine. I know how to fix this one. That's not a big deal. This is easy. This is easy peasy, lemon squeezy. This one just means your problem is that. Try it again. All right, that's a seg fault. That's a seg fault. Why? Okay, let's just stop trying to be tricky. Let's not worry about timings anymore. Why? All right, I have another way of doing this. Okay, let me do the following then. I'm gonna go here. I'm gonna add AMD GPU. I'm gonna run an AMD GPU.atTime, and then that's gonna hopefully give me more normal timings. That's what I want. I just want more normal timings. And then because the whole point of AMD GPU.atTime is so that it does that synchronization for me. I just didn't want to I did not want to have to add AMD GPU to the package because you know it's just annoying. Okay, it's okay. It's okay. Perhaps the memory on GPUs is already assigned and it's trying to read, and it goes whoop. So the fixing wipes the stack. Yeah, so I see where you're coming from with that. I don't know this specific So the issue is, it is current stack issue, right? AMD current stack info. There is something about kernel abstractions that synchronize on an AMD GPU backend that is causing this to break, and I'm not entirely sure why. I think that's something we should test, and maybe we should tell people upstream. I'm not entirely sure. Maybe. Game over. Pass the time function as an argument. Yeah, so let's just do it this way. I'm going to do this. I'm going to go here. I'm just going to run AMD GPU.addTime. We're going to remove this guy, and we're going to do AMD GPU.addTime. And we're going to do that here, there, and there. And then let's just pretend I can spell correctly. Just for once in our life. No one sees this. I'm not doing anything embarrassing right now. And we're going to do yank pay. All right, there we go. Yeah, pretend I can type. Let's just for once, just pretend I can type, okay? We're gonna try this again using, revise? Did I use revise? I don't remember. Stop being stupid, me. No. Got it. All right, now we're gonna try running it again. This time we have the AMD GPU.addTime, and we have to be using Fable intro. And now we have the AMD GPU.addTime, and this should give us at least somewhat accurate timings. If the timings are still bunk, I'm gonna stop caring. I'm gonna stop caring because I have to move on. I just wanted to get the basic timings here to see how long it took to write to image versus write to video. That's what I was trying to do here. Because in principle, writing to video should be way faster. That's what I'm hoping for. Tommy Tutos, I've encountered similar issues with running AI models on AMD GPU. Package failed to wipe memory. We're just going to move on. Those timings suck. Package failed to wipe memory, so it ran, filled the RAM, and crashed on the next run. Yeah, AMD GPU has a very finicky stack. There's a lot of different reasons for this. Is like the AMD issues on Julia are not necessarily Julia's fault, right? But it is true that Julia allows for more composability than a lot of other ecosystems, and therefore, when you are using AMD in Julia, you tend to get more of these types of issues, right? I think that is a fair statement to make. So the next thing I want to do is I want to run this very same code, and I'm just going to, instead, at time, the writing to image. And see how long it takes to write to image. At time, and let's just give this guy a go, and see how long it takes to do that. What I'm trying to see here is if writing to image is significantly longer than writing to video. And the answer is just barely. It's just barely longer. So why don't I just write to image? Why am I worrying about this whole writing to video thing? I started the stream with a core assumption that writing to video would be faster and it'd save us time. But it doesn't look like it's going to save us time. In fact, if anything, it looks like it's going to slow us down. Well, not slow us down. It's just going to... Okay, fine. All that discussion about trusting past me to know what he's doing, only to find out that I actually don't know what I'm doing. I have no idea what's going on with these timings. But as it is right now, it seems that writing to image is basically going to be the same speed as writing to video. So I'm just going to continue writing to image. It's fine for now. Keep in mind that though I do not believe the runtime exactly, it is very true that the following is true, right? Writing to image takes 0.18 seconds. Where am I? Writing the entire while loop takes 0.19 seconds, including writing to video and writing out to image. Whereas the runtime of the writing to image itself takes 0.176 seconds. The entire while loop takes 0.19 seconds. So that means that these guys must be running in something like 0.01 seconds right now, which is about right. That's what I'm imagining. All three of these kernels put together run in about 100 frames per second. That's what I'm expecting because I'm using a very inefficient method for the frame generation right now. So I'm totally expecting that that's consistent with what I believe. I don't know what these timings are. I don't know why the AMD GPU timings are giving us such bunk results. There's a lot of stuff here that I have to figure out. And why the synchronize caused a seg fault, but also like it's not my job to figure this out. I'm just going to keep going, right? I'm just going to keep going, and that's where we're at. So taking about 100 frames per second is what I'm expecting right now, in total. So that means that I'm actually going to remove the video output because, to be honest, oh, you fucking kidding me? You fucking kidding me? Jesus Christ! Why am I cursing? Let me try this one more time, because I just realized I was also. Oh, now I'm confused again. I'm totally confused again. I don't know what's happening. I was writing to both image. I left the write to video command in, which meant I was both writing out a video and writing out an image. And because I was writing both out an image and a video, that was causing extra timing. So now I don't know what the FPS is anymore, and I don't care at this point. Let's just keep moving. Okay, we're writing out to images from now on, and that's what we're doing. Okay, we're not going to do this video nonsense. It's fine. It's fine. We can do that. The API allows us to do that. There's an error in it. Fine. That's great. Pass me. Coded this up. Good job. Pass me. But let me ignore it for now. Let's just output images because I'm spending way too much time on this. Okay, we're going to do this. I'm going to do scripts, make video. There we go. Yes. Overwrite. And then what I need to do is ls here and then move output .mp4 and output basic .mp4, and I'm gonna put this into the output. There we go, and now I'm gonna change the image in the upper right hand corner so it's actually playing a video again because it has not been output basic .mp4. Okay, there we go. Now we have a video going on. Wow. I was wondering why you did that, but I assumed you had a reason. Which is why I originally asked if you stored the images on the GPU. Yeah, so I think roughly 100 FPS is what we're expecting here. It's not a very difficult image to draw, so I don't expect it to be very demanding on the GPU, and we're not doing any memory accesses outside of writing to the individual image. So with all that said, 100 frames per second, I think is consistent with what I would expect. But until we're actually doing this in real time, like with Vulkan and all this kind of stuff, the whole FPS counter doesn't matter because what we actually care about is the fact that it takes 0.15 seconds to generate each frame. Which sucks, but it is what it is. You know, even writing to image doesn't really save us here. Okay. So as far as the GPU CPU nonsense, yes, you're right. There is probably an unnecessary GPU CPU transfer, like bunch of this nonsense happening. I keep all the data on the GPU as best as I can, and then I write to a single canvas frame that is then transferred over. So, you know, everything is on the GPU for as long as it can be. But unfortunately, there is still the writing out to images. It's always the slowest part of every computation, right? Okay, well, that was what some people might call a waste of an hour, but I would call life. Okay, so let's keep going. We have that. We're going somewhere. Let's just go and start making the animation then. I want to very quickly go to that issue though and see if I actually had a response to this. So this has to do with the pixel format YUV 420 encoder option, which is enabled by default. I'm not sure what to do about this because it's also necessary for number 11. So I need to play, what was number 11? Video should output by default so videos can be rendered in Firefox and Chrome. Right. So I need to play with which options are best. Note that most people will probably choose to output images and bind them together themselves, or else choose different encoding options for final renders. This is a low priority issue for now. Right, so let me just go back. Let me just go back to what I said earlier. Backtrack a little bit. So I said earlier that I don't hate my past self because he's really good at documenting issues. Man, past me was very good at documenting issues. He was not very good at finding the solutions though. And what I'm learning is past me, though he was probably better at programming than I am now, still probably did not know what he was doing. Long story short, I don't want to spend time playing with this. We're just going to go ahead and output via FFmpeg because we know that FFmpeg is probably going to have it's going to be better anyway, right? It's going to allow us to play more with the final animation and get better encoding and all this. Existential crisis at the hour mark sounds about right. Keep it up. Yeah, so far the benchmarks are There was a comment that was made on one of my YouTube streams a while back. For the record, I've been doing streams on YouTube for a while now. YouTube.com. Let me just go to my channel up here. Channel, viewer channel. Let me go live in here. Right. So we've got 8 people watching on YouTube and 44 people watching on Twitch, which means Twitch obviously is a more popular live streaming platform. That's fine. I totally get that. In fact, that is what I would expect. I would expect Twitch to be a much more popular platform for this type of discussion, for this type of content. That said, I get a lot of comments on my live streams from people who are just annoyed that a live stream exists at all. They just get really pissed off. And they're like, I'm unsubscribing for you. I'm unsubscribing from your channel because of this live stream. I'm like, thanks, man. Thanks for letting me know, I guess. But I'm not going to stop making live streaming content because I feel like the discussion that we had earlier still holds true. Like, there is value to having a live stream on YouTube and having the VOD available in a central place. I think that's great. I might lose a couple of subscribers from it, but at the same time, I feel like this content is genuinely some of the better content I make. Even if it is a little bit off the cuff and some people don't, like it as much as my other content, that's fine. I think it's still pretty good. Spending an hour rambling about nonsense is kind of part of the game. Watch history is off. Yeah, my watch history is off. By the way, this is why I had the whole discussion about YouTube Shorts. YouTube Shorts does not work for me. I have not watched a YouTube short in a very long time, and part of the reason is because it just doesn't work for me. I have technically YouTube Shorts available on my phone that I guess I can see every now and again, but like the only time I see YouTube Shorts is when they appear on my subscription feed, because that's the only way I watch content is via my subscription feed. For the record, if you guys are wasting too much time on YouTube, which I'm not going to say you are or not, but if you're watching me, I like to think I'm reasonably high quality content, but to be honest, let's just all be honest with ourselves. If you're watching me, you're probably spending too much time on YouTube and Twitch. Just be honest. Just being honest. Probably turning your history off it's actually a very, very good way to keep you from getting distracted on the platform. It plus it also like prevents me from getting angry. Like I just. Like, everyone's complaining about AI slop. Honestly, I don't see that much AI slop on my feed. My feed is like pretty clean because I didn't subscribe to any channels that do AI. The closest person that does AI on my on my subscription feed is, well, there's people who talk about AI sometimes, but it's not very regular. Like Computerfile will talk about AI every now and again. But 2-Minute Papers, I unsubscribe from them because they talk too much about AI. I will watch Legal Eagle. I don't know if you watch Legal Eagle, and he does use AI in some of his frames, which I'm not a big fan of. But that's about the most AI content I see. And anytime AI is mentioned by some of my subscribers, I do contemplate unsubscribing. Some really good content creators to follow, by the way. Simon Clark, I would say, is one of the best science communicators on the platform. He was okay a few years ago, but he's a boss now. I would definitely recommend Simon Clark as a YouTube content, or as someone to watch if you're interested in that type of stuff. Simon Clark. Again, a few years ago, I'd be like, he's okay, but now, genuinely good content. PhD equals programming, honing, debugging. That is genuinely most people's experience with a PhD. Now, there was a discussion I had a while ago with my wife, who is a quantum researcher, and how do I put this? We were talking about using AI for certain things, and it is true that if you're doing physics, you probably don't care about writing plotting scripts. And it's one of those like one-off things you could probably like throw out. Like you don't care so much about. It's probably like morally justified to use AI if you don't care about this thing. We were talking about that. And so your discussion about programming, honing, debugging for PhDs. Yeah. I mean, you're right. There's probably too many people getting bogged down in unnecessary details of areas that they don't necessarily need to be like technically proficient in. And that happens a lot during the PhD, right? You have to have side skills in order to advance. Like to do bioinformatics, you have to learn some form of programming, but you're a biologist, do you actually need that? I don't know. It's video game logic. If you encounter enemies, you are on the right path. See, that's fair. I agree with that. Haters just mean you're doing something right. It's an existential crisis at the hour mark. I may be a weirdo, but I prefer live streams to VODs. Thank you for streaming on YouTube, by the way. Yeah, so I also, like, here's the thing. I actually think that YouTube has a better live streaming, if you just look at it on paper, YouTube is better than Twitch, right? In that YouTube has automatic quality options available for every streamer. You're able to rewind the video immediately. The chat, I don't care what people say, the YouTube chat, fine. It's actually pretty good in a lot of ways. You have this little heart button on YouTube. I mean, it's nice. I actually like it, the little heart button. I don't know what to say. It's nice, I quite like streaming on YouTube. Plus the options like for memberships and super chats and all this kind of stuff, I think those are actually more like, because the user, the streamer gets to choose when ads are played on YouTube, whereas they don't get that choice on Twitch. It means that YouTube, you can just choose not to have ads on your on your stream. Like the reason I'm not affiliated with Twitch is because if I affiliate with Twitch, now you guys see ads, right? I don't want you guys to see ads. I would like you guys to be engaging with my content, right? And watching 3 minutes of ads every hour means that's 3 minutes of you guys not engaging with my content. And it also means that at the top of every hour, I'm gonna have to click this run ad button, which means what do I do for those 3 minutes? Do I still talk like I normally would? Do I have a special conversation with YouTube people? What do I do? Like, how do I fix this solution, this situation? I would love a situation where Twitch allows me to stream without advertisements on my stream. If they were to allow that to happen, while also being affiliated, like what I want is a world where people can subscribe to me, but there are also no ads. Like that's what I want. I would like people, like I'm totally fine with the option for subscriptions and bits and all that kind of stuff, but I'm totally not fine with my viewers watching ads, right? And so on YouTube, no ads for my live streams. Twitch, no ads for my live streams. There might come a time in the future when we're getting enough viewerships on my videos and my VODs and all this kind of stuff where I consider putting ads on there. And like, there is a situation where like, let's say we're getting like, I don't know, like 100 viewers on average. Okay, 100 viewers on average on Twitch would generally mean that you're getting about 100 subscribers per month. 100 subscribers per month is generally about $300 per month. That's about $3,000 per year, give or take, which is enough for me to fund like some additional expenditures here and there. So once we get to that level, then it becomes a question as to whether the money coming in is justifiable because it also helps me do more projects faster. There's that too. But as it is right now, like I'm not making enough money off of YouTube. I'm not making much money off, and I would not make enough money off of Twitch that I would even really consider like adding ads and making your viewing experience worse. Twitch ads is like tipping. Nobody likes it, but the server needs it. Right. Please, sir, may I have one ad? This is the thing. Also, ads on Twitch are just so much worse than ads on YouTube. They are so much worse. By the way, XFF, thank you so much for following. I really appreciate it. Okay, let me get some water and let's keep going. What even was I talking about? I was going back to this issue so that I was going back to this issue so I could check to see if Past Me even had a solution to it. It turns out Past Me did not really have a solution to it. He just noted that it happened, and that's fine. Ad blocking on Twitch is atrocious. Oh, is it possible to do ad blocking on Twitch? I always thought ad blocking on Twitch was always like, just not, like, I think uBlock Origin might do it, but certainly not all browsers allow you to do it. Yeah, it's one of those things where like, I do appreciate Twitch because when you subscribe to a channel, you can turn off ads on that specific channel. And that's really cool. Whereas on YouTube, if you subscribe to the channel, the ads still play. Or sorry, if you become a member of that channel, the ads still play. Which I wish the membership option would also remove ads. That's what I wish. But anyway, I don't know. I have to admit, I aggressively remove ads on the web. I haven't really seen any in a decade or so. Mine recently broke. If anybody has a solution that would make my day, for Twitch specifically. Yeah, that's exactly the thing. I think Twitch specifically focuses on, like, Twitch will, like, aggressively fight ad blockers. Which, I mean, their entire business model is based on ads, so I get it to some extent. Okay, let me just go over here. Right, so let's just kind of, let's get some actual work done. So the next thing I'm gonna do is actually open up Audacity. Okay. Sorry about that. And okay. And I'm gonna do File, Open Recent, Open, this guy, Open. I don't think I can play this. One second. Can I play this? And can you guys hear it? I think I want to do that, turn the music off. So if I do this, it's the very start. Oh. Wait, what am I doing? Can you guys hear this? If I, you guys can, okay. So here's the video that I made so far. Look, can I just say something? I'm gonna say something before playing this video for the record. I have edited a lot of my videos, and I am very bad at making video content. I'm just going to come out and say it. I'm very bad at making video content. It is to the point that like whenever I have to like record a video, if it takes me like hours to record like 2.5 minutes of video, it does. Meanwhile, I can do the same thing on stream and it takes no time at all because it's live. And actually the live version is usually better. It's like more engaging. It's more compelling. So this is one of those where I just recorded my own standalone video. In the future, I think probably if I am going to make videos like this, I probably just want to clip my own live stream. It's probably what I want to do because I'm actually better at presenting myself live than I am in like, you know, this form. Anyway, what I want to do is I want to watch this section because I think this section here is what I want to start animating. So let me just go ahead and turn up the volume really quick. It's at 40. Let's turn this up to 100. And now let's see. So the sound goes like so. Basically, oh no, realization of your mom. No, complete with star. Stop. How this is the thing. I don't know how to do Audacity. How do I do this? So there. Okay, so here's the first little bit of the video. This visualization of your mom, complete with stars, a little comet, rings, all of that, is itself a fractal. Kind of. Okay, so that's what I need to animate. This visualization of your mom, and then I need to put a little parentheses that says not to scale, complete with stars, a little comment. What did I say? Stars, a little comment, all of that. Let me see. This visualization of your mom, complete with... So I need to get a couple timings down. Stars, this visualization of your mom, complete with stars, a little comet, rings, all... Okay, stars, a little comet, rings. So those are the 3 things I need to animate. I need to move the stars in the background. I need to somehow increase the comet size, I think is what I want to do. Or some way to like visually indicate that the comet is moving. And then rings, I need to like increase in size as well. So I'm just gonna have to find animations for those. And then I need keyframes for that as well. So the first thing I'm gonna do is I'm gonna render this. Export audio. .wave is fine. And let's do browse, and we're going to do, oh, what am I doing with my life? I want to do Laos, videos, Fable1, and then Fable.wave. Save. Okay, export. Is it done? Did it export? I don't think so. CD videos, Fable1, LS. Is it there? I guess it's there. MPV, Fable.wave. This visualization. Oh, it is there. Okay, perfect. Fine. Good. Okay. This should work fine. Okay. Apple News. What do we have here? There. Remove this. Okay. Oh, guys. Boop. Boop. Ah, the music was really loud for a second there. The music was very loud there for a second. Sorry. What do we have here? Either uBlock Origin or Twitch ad solution or Brave with a check mark on the Twitch ad removal. I use uBlock Origin, ScriptBlock, and Vivaldi as a browser. Apple News the same. You pay and get ads as a thank you. It's kind of low. Did you sing? No, I didn't sing. One day I'll learn how to sing. Not today. I'm already using uBlock Origin, but that stopped working. Let's see. MPV is great. I love MPV. So I use YouTube Premium. Haven't seen any so YouTube Premium is actually, the thing is, I think that, what is it, Twitch Turbo and YouTube Premium, I think are the 2 kind of solutions here. I think they're actually fine. Like, I think they're both good solutions. Like, I don't mind them so much. I just hate the fact, I think they're fine. As a way to remove your ads from the platform, I think it's fine. I'm not so worried about that. What's your opinion of Audacity's upcoming major update? I think Tentacle shows a bit of it as sneak peek. I don't actually know. I have never. This is like the first time I really use Audacity. I usually just use Blender for all my editing. Let's see. My recommendations are full of military and bro stuff. Let's see. Twitch ads like tipping. Okay. So let's keep going then. What am I going to do? So I have the video ready to go, and what I need to do is find specific keyframes of when I want to, what is it? It's stars. Is it stars, comet, and then rings? I think it's stars, comet, then rings. I have to re-listen to it. Now, the other thing is I want to do, what I want to do is I think I want to open it up in VLC. Do I have VLC? I do have VLC. Okay, so I'm going to open this up in VLC so I can kind of scrub through it very easier. So I'm going to do CD projects, videos, ls, CD Fable1, ls, and VLC, Fable.wave. Okay, so I'm going to scrub through it really quick. Okay, the other thing is I think I want to add, I'm going to add like a little parentheses not to scale on here so that is, I'm going to add a visualization that says not to scale for when I say this visualization of your mom. And then I'm complete with stars. That sucks. VLC doesn't give me like a direct, I'm going to have to open this up in Blender, I think. That's okay. So one thing I'm going to do is I'm going to go ahead and create an image that just says not to scale. That's number 1. So let's do GIMP. Here. And let me do close here, file, new, 1920 by 1080 is fine. I don't want a background, so I'm gonna create a new layer, close that, and then a new image. Let's see, guides, new guide by %, vertical, okay, and then I'm gonna put quick, not to scale. Grab this bad boy, put it in parentheses, that in parentheses, maybe lowercase the n to make people very annoyed. Sure, whatever. Grab this bad boy, turn this to 75, maybe 80. maybe 100. Sure. Image guides, new guide by percent. Vertical 50% is what I wanted. All right. And we're going to move this down to the center. And what I'm going to do is I'm just going to superimpose this, this not to scale. Like I'm going to put that on top of the video. So I have a way to add an image layer, and I'm just going to plop that image layer on top. So first I want to color it all white. Okay, and then I'm going to do select by color here, image. Sorry, no, it's border is one. Select, where's border? Border. Let's change this down to maybe 14. Sure, that'll do. This bad boy layer, and then should be black. There we go. File, export as, layouts, projects. What am I doing? Fable layouts, Fable intro. Where is it? There it is. Should have a resource directory. So let me go ahead and create a resource directory. All right. And then we're going to do manifest.toml. No, we're going to call it, not to scale.png. There we go. So first thing I want to do is just add the not to scale there. That's it. So we want to add not to scale for like a full second. And then we're going to wiggle the animation and stuff like that. So I have to find the keyframes. That's the next thing I have to do. Discard changes. I don't know how to find those keyframes. So I make the lowercase l and uppercase to mess with more people. Yeah, I probably should have done that. It's too late now. Your mom is so massive, she orbits the sun. Yeah, I don't know why I just said your mom. I was going to say Uranus, right? But then I was like, I probably don't want to say Uranus because it sounds like Uranus, and there's gonna be someone who jokes about that. So I said, let's just call it your mom instead. And then, you know, now I realize it is a your mom joke, and I don't know. I just ran with it. Okay, so let's go next. What I want to do is open this up in Blender and get the keyframes that I need. So open up video editing here, and then do videos, Fable 1, Fable.wave. Okay, so let's scroll down here. So this visualization of your mom, I think it's that bit right there, I believe. 1 second. Yeah, right there. So this is going to be frame 1 second and 7 frames. At how many frames per second are we? 24 frames per second. Let's bump that up to 30 frames per second because that's actually where we're at. Your mom's right here. So this is going to be 1 frame and 10 seconds. So 1 second and then 10 frames, which is going to give us, I'm just going to write this down on like a sticky note or something. There must be a better way to do this. So let me just write down keyframes. So Julia, and I'm just going to say mom is going to be equal to 1.1 times. Okay, so what is 10 frames with 30 frames per second, right? So that means we want to do 10 divided by 30, right? Which is going to give us 0.3. So mom is going to be equal to 1.3. 3, repeating. Cool. So the next one is stars is right here at 209. So this is also going to be stars is going to be equal to 2.33333. Cool. Comet is next at 310. Can I say that's 310? No, it has to be 306, 305. So we'll say comet is going to be equal to 3 seconds, 0.151515 repeating. 16, I think. Whatever. All right, this is not the best way to do this. Rings is going to start at 320. So 20 divided by 30 is going to give you 6666, obviously. So this is going to be 3.666666, and this is going to be 4 rings is equal to that. Okay, so now it's, and then I'm going to say kinda is at 708. So 8 divided by 30 is going to be equal to 266. So kinda is going to be equal to 8 plus answer. Okay, so those are all the keyframes we need. Is this the best way to keep track of keyframes? No, I don't know the best way to keep track of keyframes. I'm just doing it this way. Sorry. editing video in Blender. I do all my video editing in Blender. I don't know. I think Blender is a great tool for this kind of stuff. You guys can like say I'm wrong. That's fine. But I really do think it's a great tool for all this kind of stuff. So next thing I'm going to do is I'm going to go back to the Fable intro. We have all this stuff already defined for the keyframes we need for this particular scene. And what I want to do is I want to basically create a new dictionary, I think is what I want for this. So let's go VI source, Fable intro, G down here. And I think I'm just going to create a dictionary. I use either Blender or DaVinci Resolve for video and Linux. Yeah, DaVinci Resolve is probably also fine as well. Isn't the sound off to the left a little? Or does it just look weird in Blender? Off to the left a little. I didn't see it. But, oh, I see what you're trying to say. Was the frame, that could have been right. In which case, that's okay. I don't mind it so much because I can just add one to all of our keys. So I'm just going to create a very quick function, create keyframe. And this is just going to take in, I guess it's just going to read out a end here. Now, I never use dictionaries in Julia. I never use dictionaries in Julia. I don't even remember how to do dictionaries in Julia. I didn't know I had another coding terminal up. Oh, it's for fable.jl instead of, okay. Okay, so now I'm going to do dictionary of, I think it's something like A to, I think it's like this, 1. Is that right? Sure, that's what I want. Okay, so we're going to return dictionary of, I think we just want to do the keyframes that we just put in there. So the next thing I want to do is grab this. Where is my Julia terminal? This one? That one? There it is. Okay, so the first one is going to be mom. So mom at 1.3. Cool. Next is going to be stars at 2.33. Next is going to be comet at 3.16. Whatever, repeating. And then we're going to have rings at, what's rings at 3.66. And then we finally have kinda at 8.26. 8.26. 6666. And I think that's everything. And we can, is that all of it? Mom, stars, comet, rings. That should be it. And then in here, we're just going to go ahead and create the, what did I call it? I said create keyframes is what I called it. So we'll just go down here. I think I want to do it up here. Keyframes is going to be equal to create keyframes. Okay, good. So we have all the keyframes, and now we just kind of start, you know, working on stuff. I think this is, again, the first time I'm doing animation with this method. So probably this is like going to be immediately antiquated the moment that I do something else. Like the moment that the next animation, I'm going to have a better method of doing this. At least it's better than my attempt at splicing videos using FFmpeg. So I got to be honest, one of my favorite videos I ever made for my channel. Let me just go there really quick. Come on. youtube.com/CLEIOSOS is one that I did entirely in Blender, and it is, scroll down, this one, Don't Be Like Steve, Socially Awkward Simulation, Learning to Dance with Steve, the Kuromoto Oscillator. That one, I did entirely with FFmpeg, and I was very happy with it. Probably my favorite video editing experience I ever did. I realized that's 8 years ago, but big fan of that one. That was genuinely like one of my favorite editing experiences I had. It's been a long time, and I lost all of my skills from doing that, but it was fun at the time. Okay. So one thing I immediately realized about this is that probably a dictionary is not the best. It's not the best way to do this. But let's just kind of like, let's just do it, okay? So here we're in the game loop, or whatever you want to call it. We got CC here, and let me remove all these at times. All right, there we go. Good. So I don't know why we have a current frame in here. I don't remember what the current frame is for. The the current frame. What is that for? Round, int, current time. Am I using the current frame? Oh, I'm using it to write the image. Good. So here's when we're running all the layers. And what I want to do is I want to say that if, down here when we're writing to the final image, I think what I want to say is if, I guess probably half a second is what I want. So if time, current time, is greater than keyframes of, what am I looking for? Not year of mom. And probably I want this. So probably, I probably want keyframes of mom. Yeah, I don't want it that way. Yeah, probably. Okay, it doesn't matter. Green keyframes of mom and current time is less than keyframes of mom. Yes, I'm doing 2 axes, just deal with it. Plus 0.5. Okay, in this case, what we're going to do is we're going to create an additional image layer, and I'm going to put that into the set of layers. Otherwise, we're just going to write the image normally. Probably just grab this lines here, D to D, sorry, yank to yank, paste down here. There we go. And here, that is a very, let me just, just go in here and say file name. I'm just going to go here and say file name. File name. It's going to be equal to this bad boy here, file base times lpad, blah, 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 PNG. Great. And then we're just going to have file name is equal to file name in here. That way you don't have to think about this anymore. The $sign and the $sign, file name. If I could spell, which I can't, that's okay. Sometimes people can't spell, and I'm just one of those people. Okay, so this basically says that if we're within these keyframes, what we're going to do is we're going to put an additional image on top. Now, do I remember how to do an image layer? The answer is no. Luckily, Past Me wrote an example for how to do that. So VI examples, and then layers, image, color layer. I know I must have an image layer somewhere. grep-rl image, test layering test. Is it only in the test? It might only be in the test. Oh, VI examples image. Okay, so what is it? It's literally just grab an image layer with an input file name and then write the image out. That's it. Easy peasy. Julia lets you have the same name in local and non-local members. Yes, although you're right, that is probably a bit dirty to do so. Rook Uwu, thank you so much for following, really appreciate it. Okay, so now what I want to do is say image layer, il is equal to image layer of literally just the input file name, which is resources, not to scale.png. All right, should be okay. And then we should just be able to write that out. So we're going to do this, and the initial layer, that the back layer is color layer. So then this one is going to be the image layer. I guess I'll just keep the naming convention with iLayer in here. Okay, so now what I want to do is just kind of run this visualization and make sure that this actually runs and we get that not to scale actually written onto the video. Okay, so let's run that really quick, and we're going to run it for, I guess, 1 second. Is it going to work? I'm not entirely sure. Wait a minute. I just realized something. That first keyframe doesn't come until 1 second and 1.33 seconds in. So what I'm actually going to do here is I'm going to say start time. End time is going to be equal to 3, and start time is equal to 1. All right, see if that does it. So this should, yes, there we go. Pixel per unit between layers 1. I see, that might have been right. Okay, so what was the issue here? So the issue here is that I have this thing, this called a pixels per unit. DB compilation of method resource. So pixels per unit between layer 1 and layer 2 are not the same. Rescaling second layer. So the rescaling, but why did we have to rescale the second layer? Because it should be the same. Oh, I guess I should just define the pixels per unit here into the image layer. Let me see if that does it. Oh, I thought it was going to be easy, but that's okay. Here, and we're going to say PPU is equal to PPU. Let's try that again. See what happens. It did not work, and it didn't work for probably the same reason as before. GPU compilation method instance of GPU simple layer kernel. I see the problem. Okay. Argument 4 of your kernel function is of type matrix colors RGBA fixed point numbers, which is not of bits type. Okay, so this is the exact same thing I was saying before, that like we can't do fixed point iteration, whatever on the GPU, fine. My old animation code, I defined all animated parameters as listed in the keyframes. Then I use binary search and interpolate. Yeah, I should probably do better with the keyframes. I'll work on that in just a second. Also, guys, I have to do something really quick. I got a message from Slack, and I might have to respond to it. Give me just 1 second. Okay, I don't think I have to respond to it. Okay, that's okay. That button? Yeah, there we go. Okay. Right, so the issue with this one is that the RGB values for the image layer were defaulting to NOF8, which is fixed point iteration, and what I want them to be is float 32, so we can combine them together, I think is what the problem is. So let's go back into fable.jl over here. Nope, over here. And let's see how we're doing this. So VI source, layers, structs, layers, image layer. What layers do I have here? Image layer. And we have canvas, abstract array, params. So essentially when we grab this image layer in, we grab the image, the world size is equal to that. The array type is the array type. So what am I doing? Do I also need to specify my array type in here? Is that what I have to do? I guess so. I guess I have to force it onto the GPU, I guess is what I'm doing, so I can add them. Yeah, something like this. I shouldn't create a new image layer every time. I should instead just reuse the same image layer. And then I have a float type in here, but do I need the float type? Image layer should by default. So image layer here. What I'm trying to do is I'm trying to check canvas is array type. Where do I read in the image here? So the image layer is going to take in an image, the size of image. Okay, the image layer is here. It's just load file name. That's what it is. Okay, and do I define load, or is load defined by images? I think load is defined probably by images.jl. Let me just double check that using images. Sure, I guess I have to add it. That's okay. And then let me just see what happens if I load it. And then what I think I want to do is I want to load it, and I want to specifically load it as an RGB float 32 by default, or RGBA float 32 by default. It's okay. It's fine. Like this type of stuff takes, messing around and figuring out what works and what doesn't. I hate the fact that images requires you to build JLD2. I'm really pissed off that that's the case, I really wish that was not the case. But it is, and that's okay. So that's fine. All right. How are you guys all doing? I hope you're all having a wonderful day. Anything cool happening? All right. So we have this, and now what I want to do, I want to do load. This is by let's do, I guess, back into Fable. What? Where am I? Let me do a quick PWD. I'm in Fable intro. Oh, okay, so let me just do load. I see what's happening. Load of resources, and then what am I looking for? I think it's just one, not to scale.png. And this by default's that. So let me try doing RGBA float 32. That does not work. No method joining path, RGBA type for join path. So can I force this into load, and then I want to force this into an array of RGBA float 32, and then grab that bad boy there, and then this. Okay, what happened? There. Method of no array type matrix. How do I convert it to an array of the appropriate type then? Can I do, I think it's this then. I think I have to do this there, and then I want to do this here, and then I want to do that there. There we go, that's what I want. Computer graphics research almost sounds like AI. It's definitely not AI, but I appreciate you being here, I guess. Let me grab some water. I do have a bit of a problem though, in that, like, here's the thing. AI as a research field stagnated 20 years ago. It's like, it's one of those things that, like, sure, there is a situation, like there are new AI techniques being developed, specifically like reinforcement, and these non-neural network based approaches have been theoretically advancing in the past 20 years. But like the whole neural network machine learning thing, like this was done in the 70s. People kind of stopped caring about it for a while because we didn't have the hardware, and now we do have the hardware. Nowadays, AI research is not so much about pushing the boundaries of what you can do in AI. It's using AI to push boundaries of other fields, right? And so, like, by and large, AI as a type of research has not had a huge impact on researchers. It has had an impact on researchers, right? Like, there are papers all the time, and a lot of the papers you're going to read in the archive are based on you know, AI and stuff like this. And there are big industry pushes now to make AI happen, so that is also influencing the field of computer graphics. But, like, you know, the big thing for computer graphics, you know, last year was nothing to do with AI. It was Gaussian splatting and how that's made a return. The point is that, like, I feel like if you're outside of the research sphere, when you hear research, you automatically think AI, which is kind of fair. I guess, you know, 60 years ago when people thought research, they probably automatically thought space, you know? But even then, space stuff was probably not really a big research field as it was more of an engineering discipline. And I think that's just the world that we live in, that a lot of people tend to, like, they associate whatever the new technology is with researchers, when researchers are usually quite far advanced from that technology to the point that they don't see a need to really go into it anymore. Like, it's not, you know, I had this discussion 5 years ago and I still stand by it. You know, AI research is interesting in its applications, but not so much in its fundamental development. In that the fundamental development has not really happened recently, right? I'm writing a Python script for HAAR datasets and Oleama to catch drones in the sky. I don't know any of those words. I don't know HAAR, and I don't know what Olama is. And if it has anything to do with AI, I'm not interested. I'm so sorry. That's just where I'm at. Okay, so what do I want to do? I think what I want to do is I want to just go ahead and convert. What do I want to do? So the problem here is that the abstract array here for the canvas. So what do I do? Down here what I do is I take the array type, and when do I convert the array into the appropriate array type? I don't think I do. I think I pretty much only... Yeah, so the issue here is that, like, we have, like, a fundamental difference between the types of float32 and NOF8. That's a problem. And so what I want to do is I want to find a way to, just automatically convert those types. That's what I'm trying to do. I don't know why the image layer has to carry around the float type and the array type and all that if I'm not actually using those. But yeah, that's what I need to do. Just find a way to get that onto the GPU. So I think by default, what I want to do is I want to say this is just going to be load, and I want to do array type of float32. I'm just going to say it's float32 by default, and then load that there. I think that's what I want to do. I think that'll go ahead and do it. Control D, Julia, -- project, and now I want to do using revise. And then using Fable intro. Runs on Windows and Linux. OpenCV runs everywhere, including phones. And now what I want to do is, what else am I going to do? I'm going to do using, what am I doing with my life? AMD GPU. Go back over here to this file here. And when I grab the image layer, what I want to do is specifically say the array type is going to be equal to array type. Okay, now the next thing I want to do is grab this image layer, and I think what I want to do is I want to define it up here so we don't continually redefine the layer, because otherwise, you know. So we're just going to say keyframes here. I'm just going to find our mom layer is what I'm going to call it. Yeah, mom layer is what I'll call it. And I'm going to move these down to the next line just for fun. Okay, up there. Perfect. Let's go down to where I had I layer before. I'm going to change this to mom layer. There we go. Now let's see what happens if I go ahead and run this with Fable intro. Start time 1 to 3. In principle, what this means is we're creating that image. I don't know if this is actually going to work, but in principle, we're creating that image. We're casting it onto an array type that should be available on the GPU as well. We're doing all the writing. This should work, I think, but we'll see. I don't know what we're doing right now. It's compiling something in the background. I don't know what it's compiling, but that's okay. Sometimes you don't know what's compiling. Give it a second. It is running, and what's happening? An error. That's fine. Let's see. Argument 4 of your kernel is based on matrix color types RGB fixed point NOF8. Am I using the wrong Fable? It is currently using that Fable. Did I forget to write this? Let me see. Did I forget? No, I did not. So in principle, this should be casting this onto an appropriate array type of float32. It should be doing that. Oh, RGB, RGBA, and then float32 is what I want. That's, I think, what I want. Yes, I think that's what I want. Let's try it one more time. I have to reload everything using revise. I think that's what I want. That is what I want, right? Array, RGB, float32. Okay. Now, it does kind of suck that I'm forcing it to have an alpha layer when it doesn't necessarily have to have an alpha layer. Typecast. Yeah, I think that's what I'm doing. I'm just going to, it's a very simple typecast. I'm not going to worry about it. Okay, using revise, using Fable images, or intro, whatever. Give it a second to precompile. Then we're going to do using AMD GPU. Now we're going to do Fable intro, space example, and then hopefully this actually works. Again, this is kind of part of the problem with this project. I have to keep kind of messing around with the old code base and get it to work. But that's also kind of the point of this project. I'm trying to just kind of work through all of the kinks one step at a time. It's just going to take time, you know? So I'm not going to get anywhere near as far as I wanted to get today. But as long as I get this first couple seconds done, I think I'm relatively happy with that. You know, I don't feel like it needs to be, we need to go that much further. What is wrong with mixed layers? Argument 4 of your kernel function is of type matrix color types RGBA. Why is it still of type NOF8? I'm casting it onto something else. Okay, well, let me just very quickly then go back to Fable over here and let me just, where am I? There. And what I want to do is I just want to output the type of image, I think. So image layer file name. And we're just going to output, see print line type of image. All right, and then we're going to go back over here and recompile everything. Control D, Julia, using revise, using Fable intro, and let's see what happens. Okay, now we're going to do using AMD GPU, and then we're going to try running it one more time, and let's see what it says for the type of the image. I may have messed up somehow in that What if the NOF8 is coming from somewhere else? What if it's like some other image is being written to and I just forgot about it? Give it a second. So wait, what did it say it was? It said it was, I didn't output anything. I see. Okay. Am I not using the right version of Fable? One second. It might just not be loading things correctly. Up. Maybe that's what's happening. It's just not loading things correctly, which is fine. That's, we'll deal with that too. Oh, I have to remove AMD GPU and, what was the other one? AMD GPU and kernel abstractions. I have to remove them both from the package. It's okay. I'll do that too. After it finishes doing this. Am I dumb? Like, am I just not loading the right version? Oh, well. Yeah, one thing that I was quite annoyed with, maybe I shouldn't have been annoyed about this. So I mentioned Nightshade and Glaze, which are both tools that allow you to, so this is another thing that Hanif actually mentioned in the YouTube comments for that video, and I was quite appreciative of this, in that maybe I don't really understand how these tools work as well as I wish I did. My understanding was that there are specifically attacks on the prompt to image generation, and that other forms of like open computer vision stuff would not necessarily see the manipulations you make to the image, but a large language model would. And in that case, it would modify how, you know, it would perceive the image in the reduced symbolic space that they use. I don't remember what it's called. There's that space term that they use. But also, I couldn't even test it because it doesn't run on Linux, so it only runs on Mac and Windows. And so I was just kind of a little bit pissed off. I wasn't that angry, but it was a little annoying. So let me also do remove kernel abstractions and then remove AMD GPU. And let's go into this file again, go up to the top. Nope, not that file. There, one here. Let's remove kernel abstractions, AMD GPU. Kessler syndrome? No, I'm not talking about Kessler syndrome. I'm talking about, wait, why would Kessler syndrome come up here? I was talking about the, yeah, anyway, I was just talking about there's like a reduced space that people, there's a specific term for the space that people use so that they can reduce the state space necessary so that they can actually do these machine learning models, right? Like, it's, you know, they have to reduce that state space somehow, and they call it like, I don't remember what it's called. It's like symbolic, you know, it's like, there's a term for it. I don't remember what that term is. But basically, like, the nightshade glaze attack poison that, basically the prompt to image. It is a type of embedding space, but it's like there's a name for it that I don't remember. If I opened up the paper, I could tell you what it is. Okay, let me do. Every time I create, so every time I create an image layer, it should image. Oh, I see the difference here. So this takes a file name as a string, and this one takes it in as an image. And what I'm looking for is, so what I should probably do is I should load the image first. Yeah. Okay, screw it. I'm not going to change Fable at this point. I'm going to leave it as it is. Instead, I'm going to load the image. And I'm just going to load file name. I'm going to load it myself, and then I'm going to create a separate, this is what I'm going to do. All right, I'm going to leave that as it is. And then I'm going to go over here, and then I'm going to do mom layer. Okay, and what I want to do is the following. I want to say mom image is equal to array type of RGBA of, what is it? Float 32. And then I'm going to read this in as load and then file name, which is going to be res not to scale.png. All right, should be something like that, should work. And then I'm going to do image layer of that image. Mom image. And that one should allow me to make sure that we have the right array types. And if not, then I'm just kind of confused as to what's happening here. Control D, using revise, using Fable intro. It just means that there's something going wrong with the IO step, which we have to fix later. And that's fine, we'll fix that too. You mentioned space, and my mind goes to space instead of geometry space. That's fair. Also, Kessler syndrome is super interesting. One of the reasons I was making this engine was actually to do better simulations of Kessler syndrome. That was one of the initial inspirations and like ideas behind this engine. But I'm getting ahead of myself right now. I need to actually get it to work first. And then after I can get it to work, then I can start working on like these more, like, I guess like physical simulations and stuff. Using AMD GPU. And let's try running it one more time. Give it a second. Oh, it takes a while to compile stuff in Julia. Oh. Again, if you guys have any questions, comments, concerns, ideas, anything like that, feel free to let me know, and I'll totally address it as soon as I see it in chat. Load not defined by Fable intro. That's because I have to do using images, which is unfortunate, but that means I do need images here. Stop with the seg faults, man. Stop it. What did you seg fault for? What did you do? I did nothing. Oh my goodness. This is why. Like, you know, this is why this project takes so long to develop. It's not necessarily because, like, it's so flaky. Okay. Now I want to do using revise, using Fable intro, using AMD GPU, and then I want to try loading it. Not as bad as compiling Rust. Brew a coffee, sip, wait 15 minutes. Yeah, but on the other hand, like, you're compiling Rust. You know, like, if you've ever compiled Blender, you know how this goes. Like, sometimes compiling array, I hope that's not going to cause any issues. Okay, let's just see what happens if I run this. Maybe it's going to cause an issue. I don't know what that is. Array interface GPU arrays core extension. Cache misses, wrong dependency version loaded, mismatched flags. I hope that's not an issue. I don't know. Heck if I know. But why? Why is this an issue with my array interface? Because I loaded images? Is that the problem? Okay, so it should break about... Did it break? It doesn't look like it broke to me. It doesn't look like it broke. It doesn't look like it broke. Scroll, 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 scroll. So we should get to 60 and then... Oh, wait, there was not to scale for 1 frame. 1 frame. But we got our 1 frame, so it does technically work. I just have to figure out why it's not doing all the frames that I expected. Oh, is it because... I think I know what happened. I think when I write out to image, I clear all of the layers, and I want to specifically not clear the image layer, so I don't have to keep reloading the image. I think that's the problem. Right. So that's the problem. I should not be cleaning all of the images, right? Let me go to Fable, and let me see what's happening here. So load file name, image layer. I want to manually clear it. I'm pretty sure I gave myself VI, IO, sorry, where is it? Source, IO, and then I want to do IO tools, I think, and then mix layers. And then I think I have, like there should be a 0 in here or something. 0, 0, 0, 0, Fable layer, 0 kernel. And what I want to say is, I'm pretty sure I don't use reset unless there's a flag, if reset, and reset is by default true. So write image, wait, write image shouldn't have a reset in there. Write image is return image, and is nothing file name, save file name, and then print line. So all I'm doing is, if there's nothing in the file name, I return the image, that's fine. Otherwise, I save the file name and the image. So by this point, I already have the image by the time I do write image. So then I want a different write image because I want image with layers. And in here we have if reset. So I want reset equals false. Yes, I want reset equals false, and then I want to specifically reset different layers. That's what I want. All right, so let's go down here, G, write image, and then I want to do reset is equal to false. And then what I want to do down here is reset. I think it's layers. What is it? Reset. I think I just reset all layers. So I think it's just reset here. And then I want to read in the vector of the layers, which is going to be the color layer, Fable layer, and then this layer as well. Okay. And I think this will do what I want it to do. Let's try this one more time. And let's go. Yep. And hopefully this works. And then we have our not to scale embedded. That took a lot longer than it should have, but it's not even that hard what I just did. I just didn't know the right words to put down what I wanted to express. That's fine. Okay. Note that this takes no additional time. Like it doesn't even like, yeah, anyway. Okay, so scroll. So here's this bad boy, not to scale. And it should go off there. That seems about right. How many frames was that? That was 41. To 56, 55, 41 to 56. What does that mean? I was hoping it'd be up for about 5 seconds, or half a second. And that should be about 15 frames, right? Because I'm doing 30 frames per second. And that does look about right, about 15. Yeah, about 15 looks right. Is half a second enough time for people to read that? I guess so. I'm not entirely sure, but I guess so. Yeah, I guess it's fine. Good. Okay, so we have that part done. Now, what's the next thing I want to do? I specifically want to add in the keyframes. I'm just going to get the first, like, 5 seconds of this visualization done. And I think that's where we'll call it for today. Yeah, I think that's where we'll call it for today. And then I have to find a way to add the audio. It'll be fine. It's not a big deal. Let's see. Your frustration in its limit is approaching C. You mean the speed of light? I'm not that frustrated, to be honest. I'm actually quite... To be honest, I recognize that I'm kind of making this sound a little bit more frustrating than it actually is. I'm actually quite pleased with the overall development experience of this. I understand there's like hiccups, and like the hiccups come from Julia's side in that I have random seg faults, and the hiccups come from my own side in that Fable is not as well developed as I would have liked. But again, past me actually did put in a lot of thought into the structure of this system. And so like, for example, that issue that I just ran into, I didn't have to rewrite Fable. I already had that all ready to go because I had already ran into this issue when I was younger. And then I just had to remember that I don't have to reset the layers. That's it. Like, it's just me reminding myself that like, I don't have to, like, certain ways of doing certain things, you know? T.S. Jost, episode Laos Labs 2, hello back. The welcome of internet wonderful people, another of, yo, what's up? How are you doing? The planet stuff is animated now. Yeah, the planet looks pretty good. I think we're getting there. Like, we're getting there. Okay, so now we have to start doing the next keyframe. So this is where things get a little bit finicky. So what are the keyframes that I need to animate here? I have the stars, I have the comet, and I have the rings. So for the stars, let's go ahead and add in the ability to do an animation for the stars because I don't currently have that. Okay, so here's the stars. We just randomly distribute them in space. We spent a lot of time yesterday coming up with the PCG, blah, 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 whatever. What I want to do now is I think I want to add an additional sinusoidal oscillation or something like that. That has an additional, let's say, it must have a frequency. How's this gonna work? I want like a very simple animation. So when I say stars, it like, you know, it does something for like half a second or something. I think a full second might be too much, but half a second I think is about right. So what do I want that to look like? Let's just go over here, journal, new page before, and I'm gonna draw a little box in here. Here's my square, and in this square we have a whole bunch of stars. Here's our stars. I think what I want to do, I could do a Ricker wavelet, you know, that starts here and emanates out like this. I think that'd be pretty cool. I think that'd probably be the coolest thing I could do. Now, how would I go about doing that? I could imagine, how would I go about doing that? Oh, I guess I increase the size of the stars, right? I increase the size of the stars via some, I guess a sync function, right, is what I'm looking for. Or what function I'm looking for. I mean, it's like a Gaussian with a hole in it, right? And I think that is a sync function, if I remember correctly. Or maybe it's an airy disk. Is that what I'm thinking about? An airy disk? I think is what I'm thinking about. That's right, right? Let's see, videos? No, images. I'm looking for a very particular, it does kind of look like this, but I wanted to go in and out and in and out, right? Or I could just not worry about this at all, and I could just do like a very simple, like, sinusoidal movement up and down. And I think probably the sinusoidal movement up and down is probably the best way to do it. That way you don't have to think about this too much. Yeah, that way you don't have to think about the symmetry or anything like that. Let's just do a quick sinusoidal movement up and down. That is easy enough to do. So what does that look like then? A sinusoidal movement would look like something like, we want it to be peaking in the center and then going off like this. So does that mean we go up and down? I guess up and down. Twinkling stars. We could twinkle them. Yeah, I mean, I could twinkle them. To twinkle them, what I probably want to do is I want to create a function that takes a circle and transforms it into this object here. And then I just want to add a couple extra stars that twinkle is probably what I want to do. And so probably I want to do like a, you know, like the shiny Pokemon twinkle effect, something like this. So there's like a sweep of stars that will twinkle along a radius and just like go twinkle, 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 twinkle. You know what I mean? That could work. So how would I create this object? What does that object look like? So we do journal, new page before. We could do this in a number of different ways. The easiest way is probably to create a square, actually, and then to force this into itself like so. So we have the square with point A, B, C, and D. Okay. A, B, C, and D. Oh, D is over here, right? And then we know where these points are in space, right? So we'll say this is like, let's say -1, -1, right? And this is like -1, 1, right? Sorry, I guess this would be 1, -1 using X and Y, right? And so all we want to say is that if you're between, so we want to say that, how do we do this? We're going to say that we want to stretch it in this way, and then we want to stretch it in this way, and we want to stretch it in this way, and we want to stretch it in that way. And then all we're going to do is rotate it afterwards. That's it. So that should be relatively easy. All right, hey, thank you so much for following. Really appreciate it. Oh, your name is literally Aru plus T. Okay, cool. R-U-T? Okay, so what do we have here? How would I do that? I think one way to do it would be to, this is one of those things that's easier to do off stream because I can do math off stream and I can't do math on stream. How do I do math on stream is a question. So if x, I think it's just a linear, no, it's an x squared type of thing, right? So here we want x to be, let's say 1, and here we want the difference to be 2, right? And then hyperbolic functions, right? I think this is what I'm looking for here. And so we want if x is equal to, let's say 1, then we don't change its location, okay? So if x is equal to 1, we don't change its location in y. If x is equal to 0, then we do change its location in y. And so we're gonna do y times equals 0.5, something like this, right? So all we have to do here is we have to create some function that will allow us to, based on x, we change y. So here's, y is over here. So as x is equal to 1, let's say here, then we are gonna have y equal to 1. And when x is equal to 0, it's here. So that function there looks to me, very simply, we could just do an x squared function. That should be easy, right? So it should be x squared plus 0.5. And then we have to do some sort of multiply here. So 0.5 times x squared plus 0.5. That looks right, right? Am I wrong about that? That looks right. Yeah, that looks right to me. And so this will give us our y value. And then, so that gives us our, so let's just make sure this works. So this should give us our multiplicative factor is equal to that. So this means, just to make sure this works, it will be 1 here, it will be 0.5 at 0, that is correct. And like, let's say here at 0.25, or let's say 0.5, this is 0.5 times 0.5 times 25 plus 0.5 is going to be equal to 0.6 something, right? 6, something like this, 6 something. Anyway, that seems to work for me. It just made me realize how much more fun my grad school research would have been if I could just streamed it. I'll do it for my PhD. Oh, you're doing your PhD? Yeah. I mean, hey, how are you doing? I streamed my PhD, and it was genuinely, I have to be honest, streaming my PhD was the absolute best thing I did for my research career. And the reason was, it allowed me to create structure that ordinarily would not be there. So that's not one reason, right? I got up from 5 to 7 in the morning. Every morning I streamed. I was in Japan, so that made it so the time zones were kind of okay for people in Europe and kind of okay for people in the US. It wasn't great for either group, but it was kind of okay, right? And so I'd stream, and then I'd talk about something. And if there was something I didn't understand or something I didn't know, I would pop in, and I'd try to figure out that thing. I would stream for 2 hours. And if I did not understand that thing by, let's say, an hour in or 2 hours after the 2 hours were done, I could then spend time during the day to learn the thing so I could do it the next day, right? And so that was one of those things where, like, by structuring the day around the stream in the morning, it gave me time to learn at night so that I could make sure I was ready to do the stream in the morning. I'd sleep also, which gave me time to regenerate myself and think and all this kind of stuff. It genuinely gave me the ability to communicate, which I didn't have before. It gave me structure, which I didn't have before. And it allowed me to explore things that my grad school was not necessarily great at doing, namely computer science, right? And so when you put that all together, it was actually a really genuinely good experience, and I was quite happy with it. So yeah, I'm pretty happy with that. Really good at explaining things, and it's probably because you're constantly rubber ducking with chat. Yeah, that is, to be honest, a lot of it is that. Like, chat is incredibly helpful at, like, just, yeah, sometimes they'll talk about My Little Pony for a bit. Okay, sorry about that, that happens. But it's very useful in its ability to, like, it's one of those things. I want to see more people doing research on Twitch. I want to see more people showing their research to the world. I feel like personally, and I know this is like my own moralistic guide, and I'm not trying to impress this on anybody else, but I'm saying that, like, one of the big problems I see in society, like, it's not climate change, it's not like AI, it's none of this, right? The number one thing that I see as a problem in society is that there's a huge disconnect between what researchers are doing, what experts are doing, and what everyday people see those experts doing, right? And the reason this is a problem is it leads to a large number of, it has a word for it, I don't remember the word. It's not ignorance, that's not what I'm looking for. It's it leads to people who believe that experts are like they're fundamentally trying to, like, I don't know, take over the world. They see them as different people. Like, they do not see them as people in the ordinary sense. You know, they see them as arrogant. They see them as like they pretend that they're better than other people. This type of thing. Like, and that disconnect is what enables like other people who don't know what they're talking about to come out and to start like how do I put this? What I'm trying to explain, I'm not explaining very well, but my point is that, like, by showcasing your research, by opening it up, by enabling more people to engage with that research, it doesn't matter how many viewers you get. It doesn't matter if you're getting 1 view or 10 views or 100 views. It doesn't matter. What matters is you're doing your best to engage, and you're doing your best to encourage as many people as you can to take part in that process of research. Cynicism might be it. Oh gosh, I've not read that much Japanese in a long time. My professor might be pissed off if I do, so I need to ask him first. It is true. So I got my PhD from the Okinawa Institute of Science Technology. So I'm kind of vaguely aware with how it is in Japan, but it is true that a lot of people are still in this kind of backward society in research where they feel like, okay, if you open it up to the public, people could steal it or something. Look, openness is not only a growing trend. I'm no longer in Japan. I'm sorry. Wait, was there a time? Where does it read that I'm in Japan, by the way? So can I actually read this? I cannot, because I can't read kanji. No, my wife is Japanese, and like I know a bit of Japanese, like, you know, yeah, but my Japanese sucks. It's like I go, like, you know, anytime I go in Japan, it's like, "Hai, arigatou gozaimasu. Ah, gomen nasai. Boku no nihongo wa warui desu ne. Gomen, hontou ni gomen nasai." You know, this type of stuff. I want to learn more. I should have learned more. I was in Japan for 5 years of my life. I should have. My wife is Japanese. My kid speaks Japanese somewhat fluently. Like, I should know more, but I don't. You know, it's just we thought about going back to Japan as well. What did you say though? Let me go ahead and translate this bad boy. My first language is Japanese, so I thought it'd be easier. No. I do really do appreciate you saying this. Let me just translate it really quick. Translate Japanese. 1 second, I suck. There we go. Paste. That is Spanish. It's like we're in a situation where we don't know what they're planning. Right, I understand. I understand what you're saying. Now, what I will say is I hope that your PhD goes well. Like, I hope that everything goes well, you know? Did I misunderstand? I might have misunderstood. I'm sorry. The translation is so bad. So here's the thing. Google Translate has gotten so much worse. I don't know how to put it, but Google Translate has gotten so much worse in the past couple of years. I don't know why. I feel like I know why, which is probably because they've been embracing different AI tools, which are not actually useful for this particular like thing. But it has gotten a lot worse. I think anybody that uses Google Translate would agree that it's gotten worse. Okay, so let me just very quickly like create a simple like just star example and see if we can create like something that resembles twinkling stars. Because that's one thing that we could do. The other thing is move all the stars, which is easy to do. I think we have a function that can create the twinkle. I was saying that people don't know what experts are doing behind the general public's back, and they end up thinking that we're planning something evil, and that situation just gets worse and worse. Yeah, I think that's like, you see these people who are constantly drilling down like that. I don't know, you see that all the time. You see people who are constantly drilling this narrative that there are like these elite Ivory League, you know, like people who are like, I don't know what they're trying to say. Point is that it's, I always feel like this anti-intellectual sentiment is the number one issue we have in society, because all of the other issues kind of spring from this, the fact that people do not trust experts, right? And the less that people trust experts, the more likely it is that we're going to run into situations where there are actually world-ending threats. I'm not going to say like climate change is necessarily a world-ending threat. The Earth is still going to be here. It's just, you know, we're going to have a lot of pain coming up in the next 100 years because of that. You know, like this type of stuff. If we would have listened and actually like, you know, followed expert advice, we'd be in a completely different situation now. But we can't do that because, not just because of anti-intellectualism, but because of a lot of different things. So for me, I can't really fight every battle. But one battle I can fight is making sure that I'm open and honest and engaging with as many people as possible. And that's the primary reason I'm here. Like, you know, that's it. But it does also help with the PhD. It does help with research. And I think anyone that says otherwise just simply does not understand the process of engaging with people who maybe don't know what they're talking about, but through, you know, enough rubber ducks can solve a problem if put together type of thing. Okay, so I think the first thing I'm going to do, just because it's the easiest thing to do, is I'm going to just kind of have some sort of wave go along the stars. What does that mean? That means I'm going to have a Gaussian. It's going to appear at the center. In my opinion, the cause of anti-intellectualism is perception that education is for the jobs. I actually kind of agree with you there. The less that people trust experts, the more isolated I can be from the general public, and the happier I will be because I'm in a more advantageous position than them simply due to the fact that I have access to information the general public refuses to access. They have access, they just refuse to access it. I understand where you're coming from. I feel like doing research and learning could be a whole genre of streams. So this is something I've always wanted. So there is a science and tech category on Twitch. There is a science and tech category, and yet I'm streaming in software and game development, right? And I've always wanted to grow that science and tech scene. I wanted more people to be doing research on Twitch, but somehow the science and tech category, let me show it to you. Let me show it to you right now. Science and tech, Twitch. I think I can just find it via Google. Science and technology. It's just a shame. So we have like live storm tracking. We have Earth Community Live, we have Retro TV. There aren't that many people on the platform to begin with. Like your high stream here is 14 viewers, which, you know, I'm at 38 viewers and I'm not even really doing anything impressive. You know what I mean? So it's like, we're at a stage where I would love to see more people engaging engaging groups with their research. I want to see that. And yet at the same time, it's like, how do you do that? Like, how do you actually get people involved? Like, on the one hand, I've said this before, I don't really watch video gaming streams. I don't really play very many video games anymore, and I don't have any intention of playing video games on stream unless there is like a specific purpose for it, like community building or something like that, in which case I could see it. And yet Twitch is entirely video gaming on stream. Like, this, the majority of what it is, you know? There's a lot of just chatting now, but that's what it is, you know? And so we're in this world where, like, yeah, in my mind, and I've said this before, it's actually quite engaging, like watching people do research. I really enjoy it, but I do understand that, like, it is harder to get into research than playing a video game. On the other hand, are you actually watching League of Legends? Like, it's one of those things where it's like, genuinely speaking, the amount of technical skill that you need to be able to understand a game of League of Legends is much higher than the amount of technical skill that you would need to be able to understand a visualization of a planet rotating. You know what I mean? Like, it's just, it feels like we're in completely different worlds here. Like, for me, understanding the intricacies of the game of League of Legends is much more difficult than, like, drawing a Gaussian. You know what I mean? Like, these are completely different, like, they're just different is all I'm trying to say. So, is that Vsauce? Where's Vsauce? Is Vsauce? Oh, here? Maybe. He does kind of look like Vsauce. Video game streams are boring. So the thing is, I do agree with that statement, but I also understand that I'm in the minority, right? And most of the streams here, like one way back in the day, I used to stream on the programming category on Twitch. Programming was not a category on Twitch. It was for, like, basically me and like a few other people who were streaming on there. And I used to get a large number of viewership. That was when I had the most viewership, I think, ever on Twitch. Was back when the programming community existed, before they deleted it for creative. And then before creative turned into science and tech and software and game development, all this kind of stuff. But one thing I was very frustrated with was that they combined the programming group with the software and game development group, because I kind of felt like these were like, they combined programming with game development, because I always felt like game development was kind of a different thing, and I was always somewhat frustrated to click onto a stream, watch a 2-minute-long ad, and then after watching the ad to then find out, oh, but they're just doing game development, when I wanted to see something else, you know? And so I was quite annoyed. And what we found in the past few years is that actually the programming community on Twitch has kind of died out, and it's become mostly game developers, right? Which is a shame, because we used to have people who were doing their PhD research, and they were doing these fluid simulations, and I used to log in and love watching these people, but now I don't know how to find these streams anymore, right? And if we could just make the science and tech category big again, then we could I could genuinely recommend people to go to Twitch. I could say, hey, go to Twitch, go to the science and tech category. You're going to find some people there that are going to be interesting to watch. That's what I want to be able to say, but I can't say that. And that's where I'm at. Anyway, I'm ranting. Sorry for taking so much time with research, please. I'm enjoying your thought process with graphics research. I'm sorry. I mean, there is a dude as American president who kind of pushes that sentiment. Yeah. What can I say? You're right. Science and tech is my favorite category because I'm a nerd. Maybe I should be streaming on science and tech. Video game streams are boring because you know how to draw computer graphics, but don't play League of Legends. I don't like the programming category, though, because watching people programming is boring, and also most of them don't have any social skills, so it's boring to watch. You're enjoyable because you're also very community-oriented and talkative. Occasionally, there's electronics engineering maker channels. Oh, the making and crafting is another group that's actually really nice, and I really like the making and crafting group. They're great. Let me get some actual work done here. I would like, look, it's already 3:30. I've been streaming for 2 hours and 30 minutes, and I want to be able to say that we did something, and I would like to be able to say that we finished at least the animation that I was trying to do. So here's what I'm going to do. I'm going to first do the animation. The stars are going to be a bit tricky, and I haven't decided how I want to do the stars, but the comet and the, both the comet and the, rings should be easy. I'm just going to increase the size of the rings, and I'm just going to increase the size of the comets. I'm going to whoop, 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 whoop. You know what I'm saying? Whoop, whoop. Yeah? You guys hear? Yeah, you know what I mean. So that's going to be easy. So those two are going to be easy. I'm going to go ahead and do those animations now, and then I'll do the stars afterwards. I think the easiest thing I can do is, I don't want to do an airy disc or anything. I'm just going to do a Gaussian that just kind of goes, whoop, whoop. I have a child, and you can clearly tell based on my sound effects that I have a child. Okay, so let me go ahead and do, what keyframes do we have? Comet, rings, and then kinda. Okay, so the rings, how do I actually want to do this? I want to do increase, decrease. So what I want to do is I want to increase in size, journal, new page before. I want to increase in size, decrease in size, and then kind of wiggle back. So something like this is what I'm looking for. Now that function has a name, right? So something like this, right? And so I guess what that means is I want, is that a sync function? Is that what the sync function is? I feel like that is the sync function. Sync function. That is the sync function. That's what I'm looking for. So sine of x over x is what I'm looking for. Perfect. That's what I want. And so this will give me my size over time. It is sync. There we go. You guys know. You guys know. Make it so good. Sorry, I'll shut up. Chat. Shut up. No. Don't shut up. Look, I would not be streaming if I did not want to be constantly interrupted. The constant interruptions are kind of motivating in a way. It means that people are engaging with your work, and that's great. That's exactly what you want. You want people to engage, right? Even if I end up rambling for an hour of engagement with this type of topic, even if I'm not getting work done, is still important and is valuable, right? And that's, you know, if I really, really wanted to get work done, I would not be streaming. You know what I mean? So, okay, sync. That's what I'm looking for. So what I want to say, how do I change this size? Like, how do I shrink sync? I guess sine of x over x, right, is what I'm looking for here. And if I'm looking for sine of x over x, that means that I want to do, there's going to be some time here, right? So it's t, that's a t. I know it looks like an x, but that's a t. And then I guess let me just plot that bad boy, right? Let me plot that bad boy. So I'm going to open up GNU plot. I don't have GNU plot. Oh, are you kidding me? Let me open up a new terminal. Because again, if you ever have a problem in life, you just open up new terminals. That is, if you get nothing from the stream, that is it. Sign with exponential. I'm pretty sure I want sync. I'm pretty sure that's what I want. So let me do sudo pacman-s GNU plot. Sure. You can have my password. All right, GNU plot. Okay, GNU plot. And now I do plot x, because I completely forgot how to do this. Plot sine of x. There we go. Plot sine of x over x. That is what I want. And now what do I do here? If I want to make it so, so if I do this to 2 times x, this is going to be like that. I think that's close to what I want. And then I want to do over 2 times x, I believe, to that. Now I want to make it so, this thing curves down faster. So if I change this to be like 10 times x, what does that do? Oh no, that's obviously just, I want to make it so I want to make the envelope smaller. You know what I mean? I want to make it so it dips down faster, right? I use matplotlib because it's included Python stack. Yeah, it's just, I know GNUplot easier. I can just very easily do this, you know. I'm highly incentivized to shut up and watch you work at the moment. Well, I appreciate that, I guess. Okay, so let me move this over. You guys can't even, where do I put this? Here. One oddity with sync is that ideally you want x equals 0. Sync x sort of then, it's sort of, since it's actually a bit cosine-y. Actually, you might be right. Let me try cosine. I didn't know what this looked like. This is the first time I've looked at this. Okay, what do I want here? I want it to be, it was assigned to this. So I want to start at 1, right? So do I have to specifically do this? So that's gonna, it starts at, why does it start at 2? If 0, so I want to start at 1, and then I want it to go up. It has to increase and then decrease and then increase again. That's the function I'm trying to draw. I'm trying to do increase, decrease, increase, and then I want it to wave back and forth. I can do that by, I mean, a sine function will do it, right? So a sine function starts off at, where does a sine function start? It starts off at 0, and it goes increase and decrease. And then I want to increase and decrease again. I want that frequency to increase. Let's think of 0, 0, and near 0. What am I looking for? The function I'm trying to draw is this one, right? It goes up, up, and then down, and then up and down. And I want the frequency to increase as we go along here. So I guess that means I want this to be x times x. Yeah, there we go. There we go. Plot sine of x squared. And let me do sine of x squared over x, I think is what I'm looking for. Hey, that's almost it. That's almost it. Maybe divide this by, yeah, that looks good, right? Goes up and down and wiggles a bit. Hey, that's not bad. And then I want to change my xdims. How do I change my xdims in GNU plot again? Change xdims GNU plot. I don't remember. I think it's xdims. Is that what it is? Xdims. How do you do it again? I completely forget. X scale, Y scale. Let's see. Set terminal x, sine x, set x ticks, L margin. Anybody remember? You think it wiggles too fast? That's probably true. That is probably true. Okay. Let me just go to algorithm archive. Let me go to the plotting chapter. And here's the scale. It is x ticks, unset x ticks, x range, and y range. So set x range from 0 to 1, I believe. And then we're going to replot this bad boy. Okay, well that's not what I wanted. From 0 to 1. It only goes up from 0 to 1. I want it to between 0. How do I increase the frequency? What I want to do is I want to shrink it, right? I want to make it goes this way, right? How do I make it? How do I push it together? Why do I not remember basic mathematical transformations that you learn in high school? Why am I so dumb? I think what I have to do is multiply this, right? 2 times? Yeah, there we go. So let's do this by 10. There we go. I want it to end at 0. But it's not bad, is it? So I want it to end at 0. So if I just fudge this a bit, 9. I mean, that's not bad. 9.5. Hey. You set both x and y. Wait, you set both x and y range to 1. You need to increase the x range, I think. No, I think this is what I want. So I want it to kind of wiggle for 1 second. But I think 1 second might be too long. So maybe we do 2. So this would make it so at 0.5 seconds. If you're looking to dilate and constrict, add a third coefficient, x derived from, and wait. If you're looking to dilate and constrict, use a third coefficient times x derived from, say, one of your positional inputs. If you set both x and y to range of 1, you need to increase the x range, I think. I think this is what I want. So I want it to be, let me try setting the x range to 0.5. No, I think I want the initial wiggle and then a subtle wiggle. I think is what I want. I think that's what I want. Yeah, I think it's actually pretty close to what I want. Because this means at, I think this is pretty close to what I want, actually. I think this is what I want. I think I want, for some reason, I don't know why, but I think that this factor of 19 gives me exactly what I want, and that it ends up basically back at 0, right? I think that's what I want. It ends up basically back at 0 after a second. So there's going to be a second of it go whoosh, right? I think that's fine. Perfect. I think that's what I want. Hey, we made a math function. And I want to do the same for the, I'm going to do something different for the comet. I haven't figured out what I want to do for the comet, but for the rings, I think this is what I want to do. Okay, so for the rings, that's what I want to do. And what am I doing then? I think we just have to put that function in. Hey, so it's going to be this as our function. Okay, and use a multiple of pi. Should I use a multiple of pi? Why would I, use a multiple of pi? Is this 6.26 times 3? So 3 times pi? That might work. It goes, that's actually, I think, exactly what I want. 3 times pi. So up, down, so it goes up, goes back down. Although 1.5 is quite a stretch back down. And then up. Wait, up, down, up, down. I think that's fine. That's actually great. I think that's exactly what I want. And then I think what I also want to do is I want to multiply this whole thing by 0.5. 0.5 times that. In fact, let's just do 0.2. 0.1. 0.25. Yes, so that would increase it by 25%, decrease it by about 15%. That's it. 3 pi. There you go. We got it. Here's our stupid function. Oh, there's nothing better than coming with stupid functions to throw into your animation engine. Okay, so ring starts at 3.666, and what I want to do is I think what I want to do is I need to redefine how we've defined the rings, I think. So what do we have here? So let's go back to rings. And I think we just have a ring size. We have an inner radius and an outer radius, right? And what I want to do is set those as fractal inputs. So what we're going to do is we have fractal inputs, which we can just kind of like, we can wiggle. So we have the inner radius and outer radius, and we're just going to increase these by multiples, right? I love how much fun he's having with this. I wish I had more fun, more things like this in my life. Yeah, to be honest, I really enjoy this process, right? Tassos51, thank you so much for following. If you're looking to dilate, okay, so what's next? I think I want to redefine how I have defined this in general. I think what I want is I want this to have just a radius, which is going to be equal to half between outer radius and inner radius. So what is this going to be naturally? Let's just do, what's 3.5 plus 0.5 divided by 2? That's going to be 7.5, which is going to be 37.5. 0.375. There we go. And then we want a thickness. And the thickness is going to be 0.15. It's going to be equal to 0.15. Right? I believe that's right. Okay, so now we're going to do this and that and this and that and then this and that. And we're going to redefine this so it's based on, we don't have to do the thickness anymore because that's defined. And then we have thickness divided by current radius. And what was the current radius? Is equal to 0.3. What's the current radius? What is the current radius is going to be, what were the two things I removed? I removed an inner radius and an outer radius, but what is the current radius? So plus the inner radius. What was the current radius? What does the current radius do in this case? So we do x times thickness divided by current radius plus inner radius. What is the current radius doing? So the point of this function is to basically take our circle and to whoosh, turn it into a ring, right? That's what we're doing here. So we're taking this circle, journal, new page before, we're taking the circle and we're poking a hole in it and extending it outward. So we're pushing it out. So what was this function actually doing? This function was saying that we have some theta and we have some r. Great. Multiply x inside of sine. That might work. Here, let's take a look at that in just a second. Oh, you want an x squared. What is this x squared for? Is this for the star twinkling? Okay, so we have x times thickness divided by current radius plus inner radius. So the current radius, do I even use, we do use cosine of theta, but do we use r in this function? I don't think we do use r, do we? R? We don't use r. We use current radius. What does current radius mean? May I suggest this function instead? Yeah, what function? Go ahead. Give me some functions. So let's see. We can try out a bunch of functions, guys. Let's try out a bunch of functions. Let me get this ready, and then we'll try out a bunch of functions. Let me just go ahead and get these guys ready to go. I'll have them in GNU plot, and then we'll try out a bunch of functions to see which one's the nicest. I mean, this is kind of the fun, right? I believe that's the one I want. So to plot sine here. Oh, I think it's because this has to be that, and this has to be that. I see. So where does this starts at 0? Wait. So this needs to. Let me try changing my x ranges. But are links allowed? I think you can post links. Yeah, you should be able to post links. So generally, links are like, if it's self promotion, it's one thing. Specifically, if you're like a member of this community for a long time, I totally don't mind self promotion. That's totally fine. There's no issue with that. What is omega in this case, by the way, Max? What does that mean? Sorry, I'm looking at YouTube chat, by the way. You have something to help? Go ahead. Easings.net? Copy link? What is easings? This makes me feel uneasy. Let me do this really quick. Oh, I see. Actually, this is quite helpful. Something happened. Ah, okay, sorry. This is the button I'm looking for. This is quite helpful. Ease in, and I guess we click this. Oh, it's quite helpful, actually. Very helpful. Yeah, this looks great. Thanks for showing me. Yeah, that's quite helpful. Okay. Right, I think that's a multiply x by 10. Let's do 10 times and then 10 times here. That's actually pretty close to what I want, right? So at 0.5, let's set the x range to 0.5. Yeah, I think that's actually not bad. I use those easing functions from the website to help explore some for a paper. Very useful. Actually, yeah, thanks so much for posting that. It's quite nice. Okay, so what was I doing? Let me change my function for this ring stuff. And let's generate the ring, make sure it looks the same as it did before, and then we'll worry about this whole sizing stuff, okay? So we have the thickness, and then the current radius, which I don't remember. So, oh, this must be the current radius of the... Is that the radius of the planet? Oh, that's the current radius of the circle where we're at. That's what we're doing, right? And so all we're trying to do here is the current radius of the current circle that we're working with, right? Because we're on a circle. And so we know the radius of that circle, right? And so we're doing thickness, which is going to be 0.5. And so all we're doing here is we are taking x and we're multiplying by some factor, right? So we're shrinking the points. So in this case, we're shrinking the circle and then we're expanding it out. That's what we're doing. That makes sense to me. I'm not too worried about this. So now what we're going to do is we're adding in an inner radius. So all I have to do here is find that inner radius. Inner radius is going to be equal to thickness. Radius minus thickness times 0.5. Let's do 0.5 times thickness. Thickness. Something like that should do. Then we have the inner radius. We have cosine theta. We don't need r. We can get rid of that. Should be good to go. So this should generate the exact same thing that we had before. Should be the same. And then we can worry about adding in our functions by basically making radius a fractal input that allows us to change it dynamically with time. Good. Let's go ahead and go back over here and let's try running that really quick just to make sure our space example works. And we're going to decrease this end time to be, let's just do like a very simple end time, 0.2. And let's just do a couple quick frames. Okay, couple quick frames. All right, ristretto out, and it looks to me the same. Oh, it's actually quite a lot smaller, isn't it? That inner radius was wrong. How did I get that inner radius wrong? How did I get it so far wrong? The radius is 0.375. The thickness is 0.5. What did I say before? I said before that we were between 3. Oh, that's because my radius is stupid. 3.5, 8.5. So this is actually 42.5. Try that one more time. Give that bad boy a go. Hey, that looks pretty nice. Look at that bad boy. I don't know why I call everything a bad boy now. Everything is a bad boy. I don't know why. This is something I've picked up. Okay. Next thing I want to do is I want to modify this so the radius is defined as a Fable input and it's by default 0.425. Okay. So let's do make disk. So there we are. And what I want to do is make disk, and I want to say radius is equal to ring radius. And then I'm going to set this as a fractal input. Okay. And we're going to set this to be ring radius. And this is going to be, what was it again? 0.425? Perfect. Down here, what we're going to do in our game loop is we're going to say very simply, if, let's just go ahead and make it so, I'm just going to do the following. I'm going to say if current time is less than, what do I want to do here? I'm just going to do 1, fine. Then we're going here and that bad boy, and we're going to set, I'm just going to grab this, yank, and I'm going to paste it in here. There we go, DD there. We're going to set the ring radius is going to be equal to whatever it was before, so 0.425, and then let's try a couple different functions in here. So we know that, where's our GNU plot? So I wanted to try first this one, but I think actually this one is the same thing. No, this is the one I wanted to try. And you have you did x plus 2 squared. Wait, what is the difference here? I did 0.1 times sine of 3. I just did 3 pi of x times x. And then you did this one. Let me try this one first, and then we'll try the next one. So 0.1 times sine of 3 times pi times x. So this is going to be, we're going to have to add this in. 0.1 times sine of 3 times pi times x, where x is what in this case? X is going to be equal to time. So we're going to say x is going to be equal to current time. And we're going to have to do like minus the start time for the actual thing, but let's just go ahead and define that there. In principle, this should run, and we'll see a wiggly ring. That'd be cool. It didn't run, so we're not going to see a wiggly ring, but you know, sometimes life is disappointing. What happened here? I need a plus sign. Is that the only thing I need, or do I need more? I need to remove this. Might work. Let's do a revise, retry. Try that. And we should see a wiggly ring. Do we see a wiggly ring? Wiggly ring. Whoa, look at that wiggly ring. All right, let's do a full second. Let's do a full second. Oh, man. Looked like a good boy to me. All right. Whoa. Okay, to be fair, it does kind of end, right? Yeah, but that 0.1 is way too much. So let's do 0.01. That's going to be way too small. Oh, wow. And we'll try the other function after that. Ristretto? Why does it vanish? What happened here? What a wiggly ring. Oh my goodness. Okay, I feel like it needs to be more than 0.01. But also, why did it vanish? Where did it go? Set ring radius to be 0.45 times this, right? And if time is equal to, what frame did it break on? It broke on, that's 0, 0, 0. That's 0, 0, 1. So let me just see what's going on here. Why did it break there? We're gonna print line. Value of ring radius. DD, paste there, write that, go here, let's try that. This video match electro swing perfectly. Okay, so let me see why it broke on that one frame. I'm gonna scroll up and we're gonna see. I've got a feeling there's like some nan. We got a nan. Why did we get a nan? It vanished since it was mentioned in the sine x. Right, you're right. I need to add, let me just add a very quick, this has to be, let me add a, what's it called? For molecular dynamics, you do this thing where you, you know, like if your particles get too close together, softening. But that's still going to be too high, isn't it? It's still going to be too high. Okay, well, let me just, it's going to blow up, right? That's definitely going to blow up if x is equal to 0. So let's just actually set the current time. There's no situation where the current time is actually going to be equal to 0. So let's just give this a small offset of 0. Wait, but why when I plotted this in GNU plot was it always at 0? Oh, it's nan at exactly 0. It's nan at exactly 0. I see, I see. Okay, that does make a little bit of sense to me. Let me try replotting this guy again. So it starts out at -3, and what I want to know is how do I get this to start at 0? I want it to start at 0. So to get it to start at 0, I told you 0, 0. You told me the 0, 0 issue. You did. I just didn't understand. I somehow skipped it. You told me. You told me. I'm sorry. But there's YouTube chat here, by the way, guys. I'm just covering it up with my face because people on YouTube can see the chat always on the side. I mean, people on Twitch can too, but because it's a... You guys are right. I'm just stupid. I think softening isn't the right answer here. I think what I want to do is I want to make sure that... You'll always hit that nan, though. No, but... You'll always hit a nan there, right? You'll always hit a nan there. Weird. Okay, but let me just do softening and see what that does. Let's do softening, and then we'll try something else. 0, 1. Oh my goodness, I don't know what I'm doing. Okay, we'll grab this and we're gonna do the end time of 0.2. Okay, so now we're gonna do, what am I doing with my life? Ristretto. Hey, that's not bad. Okay, so I think softening worked a little bit. So what I want to do next is I want to go back over here and I want to multiply this by a factor of 2. And then we should have one contender for our ring animation. So we're going to do space example, and I want to do this for a full, let's do 1.1 seconds. So we do additional frames after the 1 second full animation. Scroll down, multiply it by exponential decay. Yeah, that's probably the correct answer, what I should have done, but I did not. Okay, so here would be the full animation for the full second. And go, whoop. I think it's okay. I mean, it's a nice little wobbly effect. I think that's fine. Like, I'm gonna say, with rings, yeah, it's gonna work fine. That's fine. I don't have to think about this anymore. Let's not think about this anymore. Let's just set it so it's actually the appropriate time step. So if current time is, and what I want to say, if current time is, how do I put this? If current time is greater than keyframes of rings, I think I said rings, and current time is less than, let's do keyframes of rings plus 1. Then we do x is equal current time minus keyframes of rings. Sure. And when does rings keyframe happen? Keyframes. Rings is at 3.6 seconds. So I want to do an animation from basically 3.5 seconds to 4.5 seconds is what I want to do. So let's write this, and I want to do this, and I want to do end time. So start time is going to be 3.5. Start time is equal to 3.5, and then end time is equal to 4. Sorry, 5 I think is actually what I want, because I want it to be a full second, and then, yeah, that's what I want. Sure. Let's give that guy a second to run, and then we'll go from there. Let me get some water. And that's our ring animation done. And then the comet animation, I think we can do a lot of things for the comet animation. I think what I want to do is just make it bigger. Make it increase and decrease in size. Okay, so let's do ristretto. And I think what I want to do is look at output 150. I'm going to scroll backwards. Okay. So there's going to come a time, let's see, 85, and then the one. Okay, so here's where it starts. So let's start here, and then I'll say rings. There we go. It's going to go in and out. Ah, that's fine. Nice animation we got going there. Nice animation. All right. Next thing I want to do is the comet. The comet, I think I'm just going to increase and decrease in size. But I could also do like a little swirly effect. You know what I mean? Like I can make a little sinusoidal like thing going on. You know what I mean? Everybody knows what I mean, right? Nobody here is questioning what I mean when I say right? Everybody knows. I don't have to express myself more. Like you guys know what I mean. So let's get that done. So I want to increase the comet size. I believe the easiest way to do this, I believe the comet is down here, and we have current size of the comet, which I don't think we're gonna have to modify. Instead, we're gonna have to modify comet size there and comet size here. I think those are the only two things we have to increase. So let's go ahead and set those as fractal inputs, and then I'm not sure how I want to do this one. I think probably the sync function that we did earlier would also work. Yeah, it's okay. Let's just mess around. Who cares? Nothing matters anymore, you know? Okay, let's just, the comet size. All right, we need that both for the comet shape. Okay, inputs. Here we are. Planet rotation, and we're going to do comet size. It's going to be equal to fractal input of comet size. And then we're going to do 0.04, and we're going to read these guys in for the comet, which should be the comet hole. There we go. I'm going to move this down to the next line because it looks ugly, and you know, I don't like ugly things. Comet size, and then equals comet size. All right. And what do I want to do for this one? I think what I want to do, I could do something very similar. I like your planet. Thanks. I like your planet too. It's a pretty good planet. We should probably protect it. You know, climate change and all that nonsense. Okay, comet 3.16. Let's go down here. And I think for now, I'm gonna do the same thing I did for rings. 1, 2, 3, 4, 5, 6. Yank, 6 yank. Paste it up here, and then we'll worry about that function in just a second. So we're gonna do comet, and we're gonna do comet in here. And current time keyframes comet. Okay. So the size here is going to be 0.04, I believe. I see one core problem, but let's just go ahead and give this guy a go, see what happens, and we're going to change comet size. Something like this should work. Let's see what happens. Let's go. What's the worst that could happen, right? Everything breaks? Everything's already broken. Let's go. All right, we got our image, and this should be the only other animation we have to do is the animation of the stars. Now, it's already 4 o'clock. I was going to end at 4, but I think I can push an extra 20 to 30 minutes to get the star animation done. So let's do ristretto of 150 again. I feel like the comet grew in size, didn't it? Oh, here he goes. Big comet. Look. Okay, very big comet. Very small comet. Very weird. What happened there? What was that? All right, big comet again. And then I think it remains big. I think is part of the problem. I think it remains big afterwards. All right. So good news. Yeah, this is not going to work. So let's just increase and decrease in size. No, I feel like an increase and decrease in size isn't exactly what I want. I think I want to increase in size, and then I also want to add some sort of sinusoidal oscillation to it, so it looks different. These easing functions you mentioned, I plotted them out in Desmos. Let's take a look. Copy link. Paste there. I do understand that this is more than just... Like, actually, this easings, I think I want to... I think I actually want to bookmark this really quick. Mark. Because I think I am going to be using this at some point. It looks quite nice. In fact, I quite like this. I do really appreciate that. So, like, for example, this ease out circle is going to be... Wait, where is the... Oh, I see. It requires a cubic Bezier, which I don't have yet implemented. I have not done that yet. So, how'd you do it in here? Oh, did you just do this now? That's actually quite impressive that you just did this now. That's quite good. Or had you done it before? Like, if you just saw the easings today on stream and you were able to do this, I am actually quite impressed with that. Okay, so comet increase, it just gets too big, too small. It's too much. It's too much. Okay, so what am I going to do then? I want to... I had it in my bag from earlier. Okay, that's fair. That's fair. It's still quite good. It's still quite good, but I thought you had just done it. I was like, wow, that's actually quite... that would have been awfully fast. Yeah, right. I was very impressed all of a sudden. Set comet size. So I did just want to increase the comet size, but actually after looking at the animation, it isn't that cool, the increase in comet size. So, you know, we have scroll. Okay, hello, Mr. Okay, so I think about here, the comet just grows in size. So the comet, but that's not very visible, right? Like, people don't really know it grows in size that much. Yeah, okay. Let's not worry about that then. I think really what I want to do is I want to both increase it in size and I want to give it some sort of wiggle or something like that. Now the wiggles are a bit hard in that I have to add the sinusoidal oscillation to the original comet before it gets warped around the circle. So for now, I think what I want to do is just... how do I want to do this? Okay, again, I want to get this done more than anything. Modulate the radius. Modulate the radius. The radius of the... Wait. So changing the comet size does modulate the radius. I do think we want to increase the size, definitely. I have a feeling, I feel like what I want to do is, oh, I do see what you're saying. I understand what you mean now. We have the comet radius, and we could just do this thing with it, right? And we could move it back and forth like that. That wiggle is actually, I like the wiggle. I like that. I like that. That's actually a really good idea. I like that a lot. I understand now. So we have this here, and what I want to do is I want to change, instead of the comet size, what I want to do is I want to change the comet radius. And then that will allow us to, like, you know, make it go up and down, so that it's moving. Yeah, I gotcha. And then all we have to do is have the tail follow that, which not as straightforward as you might think. Yeah, I need to think about how to make the tail follow that. But we'll get there. Comet fire. So current size, comet distance is what I called it. So what we actually want to do is a comet distance. So comet size there. Yep. Here we are. So I want to do comet distance. Okay. And we're going to do comet distance. I think I said 0.4 is what I called it. It is 0.5. Okay. And then what do I want to do? I'm going to modulate that distance. And the other thing I'm going to do is I'm going to read these in here. So where it says comet size, I'm going to use comet distance. Comet distance. Distance. And then distance. Well, actually, I wonder if there's a better way to do this, right? Like, we can add additional transformation, right? That will actually physically move everything according to a sine wave, right? We can just add a new transform to the comet, right? So here's the comet as it is right now. It's going this way. And then I can just like, I can add a transformation that will make it go like this. Like the problem is I can increase the comet distance, but the problem is to make the tail flow with it in the right way is actually going to be kind of difficult to do. Like, to make the tail flow in the right way is going to be hard. To make the tail flow. So to make the tail flow, what we're going to want to do is, now how did I do this before with the, so literally all this is a movement of its, like, all this is it is a, like, we're pressing this part of our comet a little bit down, like down a little bit. We're pressing our comet with different powers, right? So like, for example, this part would be pressed down a bunch, this part just a little bit, and this part a bunch again, right? So it looks like it's kind of like wiggling up and down. Like, this is kind of what we're looking for. So to follow that path, right? And this is stuff I don't know. I need to learn how to do this. But to do the following of that path the appropriate way, we already have it moving this direction, right? And so what we need to do is we need to have some sort of like definition of like, we need to have some sort of movement such that, like, we can add the frequency to the initial generation of the comet is what I'm trying to say. So that the whole thing moves a little bit. And then if we add that to the entire comet, then we should in principle be okay. What do we do? I need to go back to GNU plot really quick. So, because now there's both a spatial movement of the comet, and then there's also a movement in time. And I'm not entirely sure how to deal with both of those. So here's what I'm going to do, guys. I realize this is a little bit, yeah, so that's it, exactly my problem. The tail moves both in time and space. So we need a two-dimensional sine wave, I think is what we're looking for. Something that has both a time and space component to it. Right. In which case, I need to think a little bit more deeply about this. So I think what I'm going to do is the following. I think I'm going to go and close stream for now. I've already been streaming for 3 hours, and I recognize it's a little bit annoying that we didn't get that much done. I mean, we did actually do a lot, just for the record. We made it so the animation engine can now read in images a little bit better. Like, well, we didn't make that. It already could. It's just we learned how to do that again. We made the rings wobble. That's something we did. We thought a lot about the different functions that we want for the stars and the comet. And now I think I need to take a step back and think about what function I actually want for this. And then we can just toss that in there and we don't have to think so much about it. And so that's currently where I'm at. And I think that's probably a good place to go ahead and close it for now. And then tomorrow we'll come back and do more animations, hopefully, that look even prettier than the animations that we're making now. And we'll go from there. Again, if you guys have any comments, questions, concerns, ideas, anything like that, feel free to let me know right now. I think the shader language websites will have it all laid out. I'm sure it will. But this isn't quite a shader, right? In that, like, we can do more with the points than you could with a shader, right? Like, so it's because we're physically moving points in space, right? And so this gives us some more control over these like spatial manipulations. It's just a matter of like figuring out the exact right formula and stuff like this. And of course, I'm kind of targeting some difficult things to do. Like that's what I'm doing. Thanks for the stream. After this, I'll play Deltarune. See ya. Have fun playing Deltarune. I just meant the formula on the easing functions. Right. I think I know what you mean. Okay, so let's go ahead and close stream. I will see you guys next time for the next episode of Leos Labs. Have a good day, night, afternoon, morning, evening, whatever time it happens to be your time. For people on Twitch, I would like you guys to stay around for 5 more minutes. I have some Twitch-specific stuff I want to talk about. People on YouTube, I already had your YouTube-specific conversation at the start here. I asked about shorts and like stuff like that. So I have a Twitch-specific conversation after this, but it'll only take 5 minutes. And no need for the YouTube people to head on over. So I will say bye to YouTube right now in 3, 2, 1. All right, bye-bye YouTube. Have a great life. See you tomorrow, or maybe the next day.